Teacher Phillips, are you saying something?
No, but now I
Oh,
am.
oh,
And I can
okay.
hear you.
Oh, okay.
Very
Yeah.
clear. I like it. Headphones?
Mhm. Yeah.
Very good. Hi. Okay, Ariel. How are you doing?
Good. School's
Uh,
okay this year. My new,
ah,
yeah,
tell me. Yeah, tell me.
my new teacher is better, like for A math.
Okay, new
But
teacher.
yeah, we're doing functions and transformation of graphs.
Right, new teacher. It's good so far. Good. And functions and transformation right now. Okay,
Yeah,
understood. That is not, what do you think about functions and transformations?
nice.
Okay, good.
Mm.
Good, very good. What's the new teacher's name?
Uh, Mrs. Karen Chia.
Chia. You call her Mrs. Chia?
Yeah.
Okay, Mrs. Chia. Right now, according to you, Mrs. Chia is how many out of 10? the class itself. Lah.
7.
Vast improvement. All right. Yeah, give me more. Give me more.
Oh, my new chem teacher is also good because he's one
Mm.
of yeah, so that's good.
Tell me more. Tell me more. Come. Tell me more.
We're doing like I don't know, we're just reviewing the periodic table like chapter because we didn't
The,
finish it last year.
the trends. The trend.
Yeah, the trends.
Okay.
Yes.
All right. Okay.
And both of these teachers will give very clear notes. Like whatever they write and whatever they say will be
Mm-hmm.
posted in like in Google Classroom. Yeah.
Right. Whatever they write, really. Whatever they write. What? Wait, I don't understand. How do they write?
They because they have an iPad and then whenever they go through notes, they'll write their own thing on top of it using
Right.
yeah.
And then that would post it in the Google Classroom as slides or something.
Yeah.
Okay,
Teacher.
okay. So you can do your own revision now. Okay,
Yeah.
just a minute, Nicholas. Just a minute. Okay, get your stuff first. Get your stuff first, Nicholas. Yeah.
I don't have
Okay.
any stuff.
What's his name?
Huh? Oh, my chem teacher, Mr.
Yeah,
Imran.
Mr. Imran. I'm liking Mr. Imran already. And out of 10 so far?
7.
Ooh, vast improvement. I'm expecting a lot now. Expecting a lot. Okay, and you do sound happy lah, Ariel. You do. You do.
Yeah. Oh, but they put the restrictions back on my iPad, so I can no longer share good notes with you.
So I believe, yeah, let me check, yeah, because I've been hearing from everybody else, right? So there's no more new apps, right? Just no new apps. Correct, correct.
Yeah.
No new
Uh,
apps. Mm-hmm.
and because I'm using good notes from school, we're banned from like sharing notes with other people.
We cannot
So
share even with each, you cannot share even with the internal people, like your friends and everything.
yeah.
Wow. Can they share with you?
No,
So I also cannot share with you.
that's right. Yeah.
Cannot share in, cannot share out. This is really bad, but I understand. Other than
Yeah.
that, is the iPad still functioning well for you?
After they put the software, it became so slow, and I really tried to remove it. It doesn't work anymore. They like blocked the
Uh-oh.
old way of removing it. So
I'm more concerned about the slowness lah.
yeah.
Slowness.
I think they said that it will go back to normal like in a week.
Hmm. Okay, let's see. All right. Okay. Just now, experience point of view, the iPad is not an upgrade lah. Can we say that?
No. Yeah.
Okay, okay, okay. Anything else?
No, nothing else.
Okay. These two topics that you mentioned me are not the most difficult ones, and I'm very happy you are understanding them. Do we need to go through them?
No. Should be fine.
All right. Then WA schedule.
Oh wait, yeah, I'll forward you the schedule. I'll send it.
Thank you. All right. I'll go to Nicholas first. Now, Nicholas, you're not showing me stuff. I am looking at your video, but where are your stuff? Usually your papers, don't wait for me. You're a Sec 4
I have no
student already.
homework.
No homework. Okay, good, good. I'm gonna write it down. No home. Okay, that's actually very worrying. Wait, what? No homework right now. No
Because
homework.
I finished.
Because you finished. Okay, that's a different thing. Finish homework. Great, 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 great. More details, please. What's AMAT doing?
I need some help.
Yeah, what's AMAT doing? Yeah, I'm looking at it, Ariel.
EMF, I need some help.
What are you doing, Nicholas?
You mean like,
Yes.
linear law, but like I finished it,
Linear.
just finished. So
Just
now
finished.
I'm actually in the what was it?
You will be in.
Calculus, yeah.
Oh, you will now officially enter calculus, like today.
Not today, but like next lesson.
Okay, next lesson, calculus. Waiting for it. Okay, lesson calculus is starting. Good. You need help with linear law, is what you're saying.
Yeah, linear law.
Okay, so linear. Right, understand. Same teacher, same class, same everything.
And yeah, I
No
need help
upgrade.
with linear law and
Mhm.
also differentiation and integration. Like it's
Mhm.
very confusing.
Differentiation integration haven't started for your class formally, right?
Yeah, haven't. Yeah, haven't.
We'll prioritize linear law first because linear law is a big thing. It's a big thing, right? At least 7 marks in exam. No, it's not an upgrade. It's not a downgrade. Your class, everything is normal. Nothing changes.
Yeah, nothing.
Okay. Chemistry, please, update.
What do you
Okay,
mean?
Ariel, I'm looking at your schedule. Yeah, chemistry, what's going on?
Chemistry, I am okay. We are doing what is it called again? Electrolysis.
You're already at electrolysis. Wow.
No, we haven't. Correctly, we haven't even. What was the first thing we did?
Energy changes, speed of reaction.
The what was it?
Did you do
The
something?
HNOC. Was it?
HNOC. The organic chem, no, organic chem is after electrolysis. Don't worry, it's going to come
Oh,
soon. But electrolysis is confusing and hard. Before electrolysis, what happened?
it was just electrolysis. Okay.
No, these 2 weeks, what happened?
Okay.
Yeah.
I let me check.
Ariel, no WA1. According to
Wait,
your
what do you mean no
schedule.
WA1?
I don't see any WA1 schedule. Am I missing anything
Yeah,
here?
it's just electrolysis right now.
No, there's definitely a WA1. I just saw it. What do you
I
mean?
saw WA1 at term 2. Am I missing anything here?
For which subject? A
You
math or?
send me okay, I'm looking at chemistry.
Oh, okay. I think we're doing coursework for chemistry, so
Yes, project task, yes. Week 3
yeah.
to week 6 WA1.
Sorry?
Week 3 to week 6 WA1 authentic project task.
Yeah, some project.
But he said term 2. I'm not getting this.
Let me read. Sorry, because the
Yeah.
chemistry schedules for like the whole cohort.
Yeah.
What does it say?
So you just confirm with me first, yeah? Back to you, Nicholas, you're saying chemistry.
It's just electrolysis.
Wait, you have been talking about electrolysis for the past 2 weeks.
Yes, because our schedule this year is like really weird.
Tell me more.
We don't. It's very spread out,
Tell me more.
and like we don't have a lot of lessons every week for some.
And therefore, what are you doing besides lesson?
What do you mean?
If you don't have many things per week, what were you doing? What are you doing? Huh? What?
No, it's like lessons, but like it's not as much.
Not nice. Nice. Now you're telling me you've been doing electrolysis for the last 2 weeks and it is not nearly done.
Yes, not that.
Okay, scary bit. Bit scary, but electrolysis is close to the end, so I won't complain. Let me confirm. Let me confirm last year. Last year, did you do energetics, enthalpy changes?
What?
No, right? Last year, you didn't do anything called enthalpy changes, endothermic, exothermic. No, right?
No.
That's very weak. And also no rate of reaction.
Yeah, no reaction.
What's going on here? What is going on here? Periodic tables last year? Also no, right?
No
Reactivity series?
reactivities. Isn't that in electrolysis?
Correct. Electrolysis requires reactivity series. Now, are you saying that you hear reactivities the first time in electrolysis?
Yeah.
That's your teacher is very calm. Do you have a schedule for chemistry this year?
What do you mean by schedule?
What topic this week? What topic this week? The kind of thing.
No,
It's very scary. Okay. Do you need help for chemistry right now? Electrolysis lah.
no.
It's a bit scary. Have you talked about the cell in electrolysis? It's a different thing. So have you talked about battery cells?
Um,
Show me
mm,
your worksheet. Show me your worksheet. Show me your worksheet. Right. Yeah. A little bit more Ariel, yeah. Now, Ariel,
I
Oh,
need to show you my
you're not
worksheet.
very sure what to do today. Something like that?
yeah, because I already did and submitted all my homework for math and chem.
Wonderful. Wonderful, wonderful. And there are no
Yeah.
WA1 pressure lah, correct, right?
Okay, wait. So for chem, yeah, the WA1 is like very far off.
Correct.
Yeah, only I mean A math there is WA1.
Yeah, for
But
this term lah, right? Okay.
yeah. It's like week 9. Yeah.
Week 9, and the
Mm-hmm.
topics are fixed lah.
Yeah. Oh, also, like they put linear law there, but I don't know why, because technically our teacher already covered it
Teacher,
like last year.
Because it's important. Yes, Nicholas?
Oh,
you want me to
okay.
show you my electrochemistry worksheet?
The newest one lah, the newest one. Okay, I'm looking at it right now. So wait, just a minute. So Ariel, give me a little bit more, just a little bit more. I need to check it out. If you have something else to do, please do them first. Yeah.
Okay.
This is very basic, Nicholas. So flip for me. That's nice. Okay, it's basic. Basic is good. Okay, sure. Go ahead. Flip. Nothing fancy. Flip. Thank you. Flip.
Yeah.
Okay, that's done. Okay, that's the first one. Then there should be more.
Um,
Like this
that's
one. Which
same
one?
thing.
Okay, wait. Is that the first one? The one that you show me was no. The one that you show me was 15 January, which is recently lah. You haven't shown me the 9th January. Just show me the 9th January.
It's very
This one,
similar.
right? Okay, that looks very similar. It's a bit weird, but okay, let's go. Okay, let me see the back one. Yeah, let me see the back one. Yeah, let me just see the back one. Just stay there for a while. Okay. Molten. You have already covered molten. So, Nicholas, this first one, the first one that you're seeing right now, covers the molten version. The molten version is the simplest situation. Your second node covers the complicated one. Why is it complicated? The ions present are much more. That's the whole difference.
Wait,
Your ions
which one I'm talking
present,
about first and second, buddy?
you don't even know which one's the first and which one's the second. Now that worries me a lot.
No, as in the worksheet, like
Yeah, the
first
worksheet.
or
Yeah, two
second.
worksheets. The first one and the second one you compare. Now put it on the table.
No, but which is the first and which is the second?
You do not know which one is the first and which one is the second.
No, I don't know what you're talking about, first or second. Like, are you saying first as the most recent or first
Yes,
the
first by
in terms
date.
of chapter?
First by date, first by order.
So you're saying the first one is in 9th January.
Yes, that's the first one.
Okay, then can you repeat?
Okay, put it on the table. The big difference between these two is the ion present. The first one, the ion present is fewer, which makes a whole lot of difference. The second one, the ion present is more or more complicated lah, and therefore you have to choose.
How
That is
is
the
it
main difference.
more? Can you make me understand? Why is it different?
Okay, let me confirm one more thing. You do not know that these two are actually different. That's what you're saying. Let me confirm that first.
Yeah.
Okay, that's scary. Have your teacher talk about in the second one, because yes, recently lah. Did your teacher mention anything about certain things are competing, something like that?
I know, yeah. You're
Show me
talking
the
about
last page
competing
of the
like
second one again. Show me the last page of the second one. Let's see ya. Ya, lalu sampai asal pattern electron dan Okay, this is already, no, it's okay. This one is okay. The previous question. Okay, let's see this one. Good carbon electrode, concentrator, copper chloride. Okay, now Nicholas, you say you have no problem, right? Okay, this is now the test lah. You're going to do question 10, but you cannot look at the answer at all. I want you to cover the answer and see whether you can do it or not. Does that make any sense?
Okay.
It's the test. That will be the test. Okay, all we are asking for you is the reaction, the half low, both half. You don't read first lah. If you read first, then of course you can do it, right? Right? Cover it using another piece of paper, right? As per usual, take another piece of paper and then see whether you can do it. Another piece of empty paper would be good, I think. All right, that will be your test right now. See whether you're up to the class or not. Yeah. Okay, very important. Very important. Okay, back to you, Ariel. So right now, it is impossible to communicate using GoodNotes, right?
Yeah.
Using iPad, right? Okay.
What?
All right, Ariel. Nicholas, that is your thing lah. What is the
Wait,
half equation?
Do I have to Google algorithm?
I cannot hear you. Yeah, you're still eating. Yeah. Okay, we cannot have good notes.
Teacher, do I have to do the observation?
No, just the half reaction is fine.
Okay.
We have to solve that problem, right? Okay, Ariel, again, help me remember. Yeah, I've been out for quite long. At your place, there is something called a phone holder, but you don't have it with you, or you still have it or not? The
Yeah.
phone holder. Okay.
Yeah.
Okay. And your phone is still working for if we ever need to use it, right?
Yeah. Yeah. Yeah.
Good.
But if we're doing work on the iPad, I can still just I can still just share screen.
Wait, your iPad has Zoom?
Yeah, my iPad has Zoom.
Wait, your teacher allows Zoom in your iPad?
Yeah.
The other schools don't, so I guess there's a difference. So there is Zoom. This is great.
Yeah.
This is great. Okay, I understand. Good. Thank you.
Yeah.
Google Drive also have, right? Must be.
Yeah.
Okay.
Yeah.
Right. Any other updates for school? Before we end the updates.
Teacher Phillips, I can't hear you.
Oh, sorry. Any other updates for school that you want to share?
No.
Hey, Nicholas, you're peeking.
Huh?
You're peeking. Can you do it without peeking or not?
No, I need to remember the reactivity.
I'll give you the reactivity series, right? Might as well, right? So Ariel and Nicholas, practice reactivity series with me, yeah?
I wanted today to do AMF, but
Of course. No, of course. But after this, I just want to know where your electrolysis stands. That's all. Okay, here's your reactivity series, Ariel and Nicholas. This is how I teach you to memorize, okay? It should be faster than the class one, I hope, right? 1, 2, 3, dot, 1, 2, 3, dot, 1, 2, 3. The top one is group 1. Sorry. Group 1, group 2, group 3 lah. The middle one is Fe, Zn, and Pb, and the last one is Cu, Ag, and P, right? Okay, you can use that, Nicholas. Okay. For you, Ariel, you haven't touched reactivity series in your chem, right?
We just started that.
Okay. You're starting reactivity series, right?
Yeah.
How does your teacher ask you to memorize, or does your teacher even ask you to memorize?
I think, I don't know, they just said memorize it. So.
So Ariel, I'm teaching you my version now. So I'm going to repeat one more time. You're going to start with carbon and hydrogen. 3 dots, 3 dots, 3 dots. That be okay?
Okay.
Okay. The top one is group 1, group 2, group 3. So that wasn't that hard. Okay. The bottom one also the Olympic medals, copper, silver, and gold. That be okay?
Yeah.
The middle one, very middle, the most important metal, most practical metal, iron, okay, Fe. And then you have to memorize Zn and Pb a little bit. Okay, not that hard, right?
Yeah.
Okay, Ariel, I'm gonna erase that. Now, Nicholas, I'm not
Wait,
saying anything. You're saying, Ariel?
what's H again? I forgot.
H is hydrogen in this
Oh,
case.
hydrogen. Okay.
Now, Nicholas, we are stuck here. You are stuck here. Are you
No,
okay?
I'm not stuck. I'm not stuck. I'm just like, let me, mm, 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 A,
Hmm.
teacher.
Yes, Nicholas.
My mom says, re, what? My mom says hello to you.
Hi, 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 chị. Can your mom hear me? Sorry, can your mom hear me?
She
Nicholas?
can't. I forget already, actually. I don't remember anymore.
Hey, please say hi to your mom first then.
She say hi.
Then please say hi back to her.
I tell her already.
Thank you. Now, Nicholas, I'm gonna revise a little bit and then we go to AMAT. Okay, just a little bit. Because my guess is if you don't understand this part, and your teacher rush through, hopefully he does not laugh out there. So then you'll be lost in the last part. Okay. Ariel, when you're done, tell me.
Okay.
Does your teacher tell you the electron flow is the most important thing? Something like that. Nicholas. Nicholas, can you hear me?
Yeah, hello.
Okay, I'm repeat one more time, yeah? Listen carefully, yeah?
Yeah.
Does your teacher tell you the electron flow is the most important thing to start with?
I think so.
Okay, then tell me, where is the electron flow then?
Like the from the anode to the cathode or something. What's electron flow?
Okay, Nicholas, I want you to stop clicking your mouse and listen to me. No more doing anything else, okay? Okay, grab your pen and draw this thing. Okay, focus on my screen and nothing else. Come on, draw this thing quickly. Ariel, have you done memorizing?
I just need to write it out like one more time.
Correct, correct. And then you have it memorized. Very good. Nicholas, the electron comes out from the -1. If you don't know that, then you memorize that and then that's it.
Comes up from the -1.
Right. And then the electron will go in the +1, something like that. Okay. Now this affects everything. That means the guy here, whatever the reaction in this guy, will have to accept electrons, and whatever the reaction here will have to lose electron. This one will accept electron, and this one will have lose electron because the electron is being forced to do that. Would that be okay?
Yeah.
Right. Now, in the reaction that you have you written something that accepts electron, or have you written something that have lost electron?
In my reaction.
Yeah, you at least wrote one reaction, ma. So that reaction is accepting electron or losing electron.
Accepting.
And that will be correct. And therefore, you put it here. Cu2 plus 2 electron equals to Cu solid. I love that. Okay. The placement matters, yeah. I'm not caring about anode or cathode right now. I don't care about it. I know teacher cares about it a lot. I do. Now, that means this guy will be losing electron. This guy here. And you have mentioned that, hey, it's going to be Cl minus. Actually, it is a good guess. Okay. How do you write losing electron? Do you know?
I don't know.
Okay, then the logical way is Cl minus electron. Make sense or not? That seems to be a very wonderful way of writing losing electron. 2Cl minus 2 electron become Cl2. Would that be okay?
Okay.
Right? And then your teacher will say, but in chemistry, there is no such thing as minus. They don't like it. So do a dollar door.
Oh,
You have heard this from me last. Now, this is what it looks like to lose electron. It doesn't make sense actually. Sorry, it's very difficult to make sense, but that is what it means to lose electron. The plus is on the other side because actually there is a minus here. Actually,
okay.
but they don't like it. So again, back to plus 2 electron. Understand?
Yeah.
Now check out your equation first quickly.
All right.
You're correct, right? Now, here's the real test. Okay, close it again. Now this is concentrated hydrochloride. Look at the picture. Look at the picture quickly. Okay, that's concentrated equals copper chloride. Now I change the question a little bit only. This is going to be dilute equals copper chloride. Dilute.
Wouldn't it be that eventually it means that the loose E minus is OH minus?
If you're saying that one of the reaction changed, I'm happy. But tell me which one. Tell me which one. You're right that if it is dilute copper chloride, something will change. Tell
Yeah,
me.
yeah. It's the instead of chloride losing E minus is OH
Then
minus.
write something for that, please. Write something for that. Okay. Like just, okay, this is now wrong. So yeah, write something else. Good. Ariel, have you done memorizing?
Yeah, done.
Okay, good. Now, can you go, no. Have I shared with you the Google Drives for AMath, Sec 4, and, chemistry, Sec 4?
A math, yes. I think chemistry, no.
Okay. Does your school have their own question bank for chemistry and AMath? Just checking.
Question bank.
That means you have access paper. Last year, you don't have anything like that at all. Nothing. But maybe this year you have.
I mean, we don't have a question bank, but I guess we can access like our school's past papers.
Okay. Can you go to just one of your school's past year papers for chemistry?
Oh, wait. Okay.
Yeah. Just do that, and then I'll tell you what to do. Wonderful balancing, Nicholas, except that they want the state symbol. Can you do that for us?
Huh?
They want the
Oh.
state symbol very much, so that would be nice.
Okay.
Okay, nice. Very good. OH minus.
Equals.
Wonderful. Do you have this thing for OH minus blah, 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 memorized?
I know I have to memorize it, but I haven't memorized it well.
Right now, memorize it. I'll give you 20 seconds.
20 seconds.
Yeah, you now have 10 seconds left. Now, flip your paper and rewrite that again. It will serve you very well. Come on. Even if you forget, it's okay. Flip your paper. The way to memorize is not to look at things, but to rewrite them. Please rewrite them, I don't know, using your piece of paper. Yes, it'll be fine. As much as you can. Good.
Okay.
Wonderful. Ariel, tell me if you have a problem or if you are done, yeah?
Wait, yeah, I have a problem. I don't really remember like where our past papers are.
This is important for this year. Maybe
Uh,
spend 3 minutes looking for it. Would that be okay? Wonderful, Nicholas. You check whether it's correct or not.
Yeah, correct.
Wonderful. Now, rewrite the metal reactivity series again. My style. Again, my style is you start with carbon, you start with hydrogen, 3 dots, 3 dots, 3 dots. All of them. Come on,
Three.
rewrite them.
I do, am I correctly, have
Hey,
already
just write it down. Just write it down. Whatever doesn't work, we'll fix that lah, of course, right? But my style. Okay. Where's the carbon? Where's the hydrogen? That one's carbon. That's hydrogen. Okay, then everything else that you remember.
by the way, I don't know what 1, 2, 3 even means.
Group. Metal group 1, metal group 2, metal group 3. Okay, continue.
all.
Yeah. So continue.
I don't know anymore.
Come on, the bottom one is the medal, the Olympic medals. Come on, your best.
Bronze, silver, gold.
Yeah, but bronze, don't say bronze lah, say copper lo. Hey, the bottom one. The bottom three. The bottom three, yes. Yep. Symbol for silver, focus. Nicholas, symbol for silver.
Right.
AG. Don't look at it,
Um,
AG. Yeah, AG. And then symbol for gold.
I don't remember.
AU. Now, the middle three. Right in the middle is the most practical used metal. What is it?
Middle.
Yeah. Focus, Nicholas. Focus. In the middle, the most used metal.
The most used.
Come on. Your table legs.
Iron.
Iron. Yes, iron. Come on. Write down.
In the very middle.
Yeah, in the very middle. That is the most used metal. It's very convenient.
I don't remember what the.
Fe is the symbol for iron. You need the symbols. Come on. Fe. Don't touch your
Fe.
mouse. Okay. The top is the zinc. The bottom of Fe is Pb, your lead. Give you 1 minute to memorize this, and then we're going to rewrite it again. Okay? This is important. We have to memorize this right
Wait,
now.
wait, Teacher Phillips, I don't know where the
Yes.
link is. I asked in my class chat, but
Yeah.
no one has read it. So
So you're saying that the existence is not confirmed or it's there? Just
no, it's there. I just don't remember like what is listed under.
you can't find it. I mean, it's a very complicated thing to find, something like that.
No, it's in the drive somewhere, but I don't remember like what the name is. So I'm like searching all the possible keywords.
You don't just have you tried chemistry and see what happens?
No, but it's all together in one thing. And I can't find that. I have no clue what it
It's
is.
just depressing, right?
Yeah, because I know it exists because I've looked at it before.
Your
Probably.
school name is?
Methodist Girls' School. I already checked that.
Okay. Try IP, right? IP program, right?
Yeah, I tried that too.
IPY4? No?
I tried everything. I've tried IP year for IP/IP, past year papers, MGS, school drive, past
That's
papers,
depressing.
everything.
Okay.
I feel like it's under some funny name.
Okay. Is it easier to find my shared drive?
Yeah, I have it starred.
Yeah, because you should be starting them now, so you know how to start them. Okay. Right. For now, I don't have you don't have cam. You don't have the cam. My goodness. Okay, I have to share it with you. Right. Okay, cam. Nicholas, are you ready? Ready or not? Flip to an empty paper and redo it again. Come on. Ready or not? Come. Your memorizing is good if you use the proper technique lah. Your email, Ariel. Something
Ariel.
Ariel.
Yeah, it's there. It's there.
Okay, all right. Okay. I'm showing you the O-level chemistry first. There you go.
By the way, teacher,
Yes.
when you mean group 1, group 2, group 3,
yes.
there's like 2 elements in each of them.
Correct. 2, 2, and 1 lah. You do need to memorize them later, but for now, you need the whole structure. Please, Nicholas, focus on the whole structure right now. Good, thank you. Now, Ariel, you go to this folder lah. You'll be seeing them, right?
Mm-hmm.
Okay, if you choose just a random one, whatever, 2016 or whatever, you will be able to go to you'll be able to search. So the MCQ lah. Then
Okay.
you just search reactivity. Then
Okay.
a lot of questions will come out and you choose the MCQ one only for now. Can you do
Okay.
that? Okay, you only missed one, Nicholas. Just check it out. Which one is wrong? Only one. It's very proud of you. Only one thing is wrong. You just check the previous page. Now, Ariel, when you're done, I want you to look at them and screenshot and share with today. Right? So yeah, wonderful, Nicholas. Good. Now, Nicholas, the negative reactivity series. Have they do it with you? The non-metal reactivity series. You need it actually. No idea.
First, can you explain to me what you mean by 1, 2, 3?
Okay, good. Now I'm giving it to you. Ariel, is the search okay? Just checking.
Yeah, I'm just gonna screenshot and send.
Good. And maybe 2 or 3 questions, and we're gonna start with that immediately. Do not worry. Our style has always been to see what's going on in exam. Okay. Now, for you, Nicholas, the group 1 is, well, if you have remembered, good. If not, additional remembering, like K and Na. That's the order. This one is calcium and Mg. And for aluminum, for group 3, there's only 1. Do you want to remember them right now?
Okay. Wait. Yeah, wait. Let me just see first. Wait.
Hey, stop touching your mouse.
No, I need to look at periodic table to see. K, N, A, M, G, and then
CAMG. Look at my screen. Look at my
aluminum.
screen.
Aluminum is not.
Group 3.
K and A, that's group 1. C and G, that's group 2.
And Al is group 3. That's it.
Wait, aluminum is in group 3?
Surprise. Now you know.
Wait, what?
And that's why you
It's not.
memorize things sometimes, some things. Could you memorize them right now? I guess you.
Wait, no. It's not.
Nicholas, this is not a time to debate, okay? Aluminium is periodic table group 3.
Group 3, I see scandium, yttrium, the lantanoids, and the actinoids.
Hey, Nicholas, just memorize the reactivity series, please. You're going way too far. We're wasting time here. You want A math, right? Right? We'll talk about periodic table later.
Aluminum. You mean, so you mean like group 3. That is so. Teacher, you mean group 3 as in like not counting the ones in between, right?
Yeah, just aluminium finish. Yeah.
That's so confusing. Okay.
I sent 3 questions.
Okay. Let me go there. Very good. Very good. Very good, very good. Okay, I like the first one. Second one is basically the same. And also the third one. Believe it or not, all these are the same thing using the same logic lah. Now you're saying that your reactivity series is starting, am I correct? Okay, you have no idea what's going on yet lah besides the reactivity series. Am I correct, Ariel? Ariel, can you hear me?
Sorry, I didn't realize I was muted.
Okay.
Yeah, but no, I think I can figure it out.
You can figure the questions out?
Yeah, I think so.
Okay, try. I'm very curious. The question represents the essence of reactivity series, so that would be nice.
Okay.
Okay, give it a try.
Okay, so teacher,
Yes.
I need some help with A math.
No. We have one last thing. The negative reactivity series.
Negative reactive.
Yeah, it looks like this. So I just want to confirm that you have it. Okay, with an O. Well, sometimes they don't call it just like that. Maybe just something like that. It's a much shorter version containing non-metals. Have you seen this before? Has your teacher talked about this before?
FOClBri. What's OH? Wait, no, this. Wait.
You have never seen this before because
No. Wait. I need to check
this.
something.
You actually need this actually. You already are needing this.
I'm just checking something real quick. Wait, is it electrochemist? Is that you? That's F, right?
The FOClBri, this kind of thing. Does your lecture note have this kind of thing? You need it.
Wait, can you see what's called again?
FOClBri.
No, the name.
What do you mean? Oh, they call it the negative reactivity series or the non-metal reactivity series.
You mean the selective discharge of anion?
Yeah. Nice. Yes. Can you show
I'm
me that?
looking at it, and
Can you show me?
F
Can you show it to me?
isn't in there,
Show
nor
it to me.
is
Show
oxygen.
it to me. Yeah, show it to me. Show me what you're saying. Yeah, well, it's in your textbook. But this is not what we want. We don't need the sulfate. We don't need the nitrate. And we need the OH. Yeah, there you go. There's the OH. There you go. The OH. Well, I guess some will call it OH. And then that will be correct. That will be correct. Now, has your teacher ever referred to this?
Yeah.
Then let's adjust to, okay, because fair enough, F is very rarely used. So, but you don't get it that, why? Why does your teacher do it that way? Never mind. Since I know you know, I will refer it to it next time. Now, are you sure you are okay with your electrolysis for now?
I'm okay with it.
I'm okay now. Okay, now ask your AMAT question, please.
I just need help because linear law, I cannot understand the fact that like the answers are wrong. Like I cannot like feel good about the answers because I saw.
Show me. Ariel, are you doing okay?
Wait, let me
I'm
give you an
done.
example.
You're
Let me give an
done.
example.
The 3 examples you can answer.
I don't know if it's correct.
I know you have the answer key. Come on.
Oh, okay, wait, I'm gonna go check the answer key then.
Yeah. Don't wait for me like that. Don't wait. But I'm very good so far.
Teacher, let me show the email. Yeah, teacher. Look.
Yeah. What is it?
This is a question that I was doing before.
Reasonable. Okay.
For linear law.
Reasonable.
And like, I cannot get over the fact that like this is still correct, even though like I don't like that the answer is broad. Like, isn't just like one set answer.
Okay, you gotta tell me which one is confusing you. I can understand your working. Which one is confusing?
The one that's confusing me is that there's multiple answers.
Wait, you mean your graph cannot be the same as other people's graph, so therefore the answer can be slightly different?
Yeah.
Because
Yeah.
you're right, right? I mean, a graph is a drawing thing. Your graph will be slightly different than
No,
that.
the difference is that in linear log, in this one, right,
Mhm.
the graph is not exact.
Correct. Precisely. Yes. That is what you should expect. It's slightly off here and slightly off there, no matter what you do.
Because of that, the gradient will be different.
Slightly different. Yes, you
And
are
I'm still correct because that
because it is within the range. Now, what worries you? Tell me, what worries you?
because it's different. This is still correct, but this part 3 is wrong. The answer is 1.47, but I got 1.44.
Because you're using the value from the previous one, correct?
Yeah.
How come the previous one is correct and then the next one is wrong? Something like that. But who say that your answer is wrong? Because 1.44 and 1.47 is very close.
Eh,
Oh wait, yeah. I remember.
It's very close. I would mark it as correct. Just say. Yes, Ariel, how is it?
wait, I'm looking for the answer key.
Okay.
Cause like it's somehow not in order. Wait, I'm like looking for
Okay.
it. Um,
Wait. Okay.
Yes.
This is
Yes.
what I'm confused about this. See.
Okay. The graph is harder to define. Yes. Still looks good though. I'm okay with your graph.
Still good.
The one which is very off, the second point, is by design of the question. Usually that's the case lah. Usually. It represents a point in an experiment which may have some errors in it. It's meant to be like that, I suppose. Meant to be like that. If that's what you're worried about lah. That's actually a normal feature.
Really?
Now, is that what you're worried?
Yeah.
Now, I'll tell you how to not be worried about it. If you look at the question and the question asks you to identify some sort of an error point, then you know that you are right lah. Does the question mention anything like, oh, there's a point which is just way
One
off?
of the values of y is believed
There
to
you
be.
go. There you go.
Oh
There you
my
go.
days.
That's it lah. Your worries are actually confirmed by the question. That thing is wrong, man. That thing is just off, man. You understand?
Oh, okay.
Okay, you okay, yeah? It is by design, not all linear law question, but they do sneak in one or two lah, right? They do. They do.
wait.
Yes, sorry.
I got one question wrong. It's the one that's question 20.
20. Let me see
Yeah.
question 20. I'm very happy that you get two right. Right? Question 20.
Wait, because this thing is just like, oh, if it displaces it, then more reactive, right? Yeah, I think
Uh,
so. Kind of. Is there?
I mean, that means you have learned something, right? So, okay, like this, huh? Like this. So, I'm going to say something. So, there is I'm going to draw something for you so that see whether you make sense. Now, Nicholas, are you going to ask something else? Looks like your questions are very valid and very nice, and they're very exam ready. I like it very much. If X cannot displace W, then WX like that. Make sense? Ariel?
Yeah, that makes sense.
That makes sense. And then looks like Z plus displaces W. So Z is on top lah. Make sense?
Yeah.
And then finally, the third one doesn't matter for now.
Wait,
Uh,
that's what I put, but the answer key says it's not. Okay,
oh,
maybe
oh, oh, sorry. Okay, then you have
Wait.
to know a little bit more, okay? A little bit more. This is a bit far. So the only carbonate that cannot be heated, that means no reaction, is sodium carbonate. So this is,
Uh-huh.
sodium and above, sorry. So
Yeah.
basically, he's telling you that Y is sodium and above. And
Oh.
by telling you it is sodium, he's hinting you that sodium is quite far off, far above. Because sodium, or in this case, Y, is very far on top of the reactivity series. That's why it's like,
Uh-huh. Mm-hmm.
okay, so then it matters lah. It matters. Now, decreasing reactivity will probably mean this and that, loh, something like
Wait, what?
W. There is no Z. I'm thinking of. Wait a minute. Wait a minute. Wait a minute. Oh no, 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 no. What am I talking about? This is X and this is Z lah. Sorry. Yeah, correct, correct. No, correct, correct, correct. If X plus cannot displace W, that means X is on top. What am I talking about? Okay.
Okay, wait. Can you repeat that? I'm gonna write it down.
No, 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 no. I will teach you the logic. Now, Nicholas, do you have something else to ask me? Because if not, I want to give you a few practices.
No.
You're very sure? I'm happy with your linear law questions.
Wait, no. About what's it called? Integration, differentiation. I just cannot understand.
No problem, no problem. But let me confirm that your school is not starting, right?
Yeah, just started yet.
Okay. Now, just check that you have access to my Google Drive O-level AMAP. Just checking first.
Let me get that.
Right. So for you, Ariel, I'm going to explain the logic behind it. Usually teacher don't do that. The logic is actually pretty simple once you get it. That be okay?
Okay.
The reactivity series, which I only focus on calcium and iron here. Please confirm calcium is on top of iron, correct?
Yes, it is.
Okay. The reactive series actually have a mirror image down there. The mirror image is exactly what it means, mirror image. But the image contains the ions. Fe ion, right? Calcium, calcium ion in a mirror image fashion. Would that be okay?
Yes.
Now, that means in that sense, your XYZ, whatever, so there's a W here, right? So W is on this side of the mirror, which means there is a W plus. Let's just call it that way. There is.
Uh-huh.
And then X plus will be in either two places, like it's either here, here, or here. But you can never put an X2 plus there. Cannot be. X2 plus always is on the bottom mirror image part. But it can be here or here lah. It depends which one. Now,
Okay.
I put this as the red one, so that it's not confusing. This is the red X2 plus, and this is the pink X2 plus. Sorry, there's no plus here. I'm not talking about. It depends on which one. One of them will be correct. So far, so good. So these are the two options that you're dealing with right now. Which one is correct, the red one or the pink one? Okay,
I'm still a bit confused.
no problem. Just a minute. Nicholas, have you found the O-level AMAT?
Yeah, wait, I'm still trying to find. It's like very,
It should be in the
very
shared
deep.
folder. Share with me folder. It should be there. If not, I'm supposed to share it.
Can you share again? Oh, I think I found it.
Okay, good, good. Open a AMAT paper, and I want you to open it, and I want you to find what you think are differentiation integration questions. There will be so many variations. I want you to take, I don't know, 3 of them. Just like that. I'm going to discuss them. That's simple. Now you have to choose and screenshot to me first, yeah, today. Ariel, let's focus on the top one first, because that's what your teacher tells you. There's only top one. I'm telling you there's a bottom one also, right? Okay. The X will be either on top of W or on the bottom of W, lah. Correct or not?
Yeah.
So that's just a question mark here. Now, would you believe me? Okay, if there is an X here, then there must be an X plus here in a mirror image fashion. Is that what is confusing you?
Okay, no, that makes sense.
Okay, then the X pink will be X2 plus, but of course the X2 plus will be here in a mirror image fashion.
Wait, why there 2x2 plus?
Because the pink one must have, and the red one must have lah. But
Oh,
there's two
okay.
because we haven't decided who to eliminate. One
Oh,
of them
okay,
is right
okay,
and one of them
okay.
is wrong. Okay, it's just a
Okay, okay.
decision thing. Okay. So don't let that confuse you. Now, basically, you notice that when you're talking about a reaction, you will notice that it's always a x2 plus with the W. It's never x and W.
Uh-huh.
So therefore, the proper location for the x2 plus is actually not an x. The x2 plus is actually at the bottom mirror image one. Okay. And
Okay.
when there is no reaction, it goes something like this. When there's no reaction, it goes something like this. Huh? The W, when there is a reaction, there is no other way but for W to become W2 plus. There is no other way. That is what it means.
Wait,
Look
wait,
at the reaction.
W2
Mhm.
plus or just W
Oh, W
plus?
plus, sorry, W plus, W plus, sorry. There's no way but to become a W plus. So in that sense, there's no way but for it to drop down.
Uh-huh.
Okay.
Okay.
Now, if there is a reaction, there is no other way but for the x2 plus to become x. There's no other way. So in that sense, he will be jumping up. If there is a reaction, if there is a reaction.
Okay, so basically what you just said is that if there's a reaction and X is involved, it will become X plus.
If it started at x, it will become x plus. If it started
Okay.
as x plus, it will
And
become
if
x.
it okay, can.
It's that simple. Look at all the reaction. Or if z has a reaction,
So it's just you lose or gain one electron. Okay.
either losing or gaining. It's very simple.
Okay,
It's
can.
always like that one. It's so simple.
So so so
Now, mhm,
uh
go ahead.
so like this mirror image thing is just showing like that. Okay, can.
That thing,
Okay.
that's all, that's all. And I am making the x plus appear finally, x2 plus.
Mm-hmm.
Because originally, you don't see any x2 plus in your truncated reactivity series, the one that
Mm-hmm.
you're teaching. So where's the x2 plus? Are you saying the x2 plus is same as x? Not at all. It's not the same, but it is never shown. I'm showing it for you.
Mm-hmm.
I think that's very important. Now, this immediately to me tells me why there is no reaction. I will choose this guy. This guy is the reason why there is no reaction, and therefore this guy is wrong. Okay, but why?
Uh-huh.
Why is that so? Why is that so? Because in this situation, the jump up is bigger than the jump down.
Uh-huh.
Every reaction, which is automatic, must be the jump down bigger than the jump up. Because
Uh-huh.
why? The jump up takes effort.
Yeah.
The jump down, well, is automatic or releases effort lah, releases energy. If you
Okay.
want the reaction to happen, the jump down must give off more energy than the jump up required, if that makes sense.
Yeah, makes sense.
So if I place the x plus here, my jump up will be greater than the jump down. Therefore, no reaction. Therefore, this
Oh,
reaction cannot happen. If I place it here, hey, the jump up is smaller, lah. The reaction should have happened. But wait, there is no reaction what? So this is wrong lah.
wait, I have a question. How do you know that I can only gain or lose one electron?
Oh, in this case, the question tells us W becomes W plus. That's all.
Oh, okay.
It tells me.
So
So I don't have to guess. I don't have to guess.
wait. But aren't you just like assuming that oh wait, because there's two
The question
reactions
tells
with
you.
W. Oh,
Yeah,
because there's
the
two.
question
Oh,
tells you,
okay.
actually, the question tells you at the start immediately.
Oh, because they form cations. I didn't read that. I don't know why I didn't
Yeah,
read that.
yeah, correct. Okay, they
Oh,
tell
okay.
me, so I don't have to
That
assume.
makes sense. Oh, so this is essentially just like logicking out by if you gain this much, then like cannot be above or below. Wait, that makes so
Something
much
like
sense.
jumping down must always be bigger than jumping up.
Oh,
If
okay.
it is not, no reaction. It's that simple.
Sure.
It's really, really that. Yes, back to you. So Ariel, do more reactivity series question. Now the paper 2. Yes, Nicholas, can you find it?
I think I found one.
Could you just screenshot to me for today?
Okay.
Let me see your choice. Everything will be difficult, but that's what you are ready for difficult things. You're so ready, man. Okay, I'm looking at it. Okay, this is actually not very difficult. Would you like to try?
Oh yes, but like, let me have a break first. I have to go toilet.
Okay, about 5 minutes.
Oh
See you.
yeah, me too.
Now, go ahead. Go. Nicholas, go to the toilet. Come on. Guys and girls, ladies and gentlemen, is anybody there? Ariel, yes. I didn't know you're back. You're back, huh?
Oh yeah.
Would you like to start first?
Huh? To what?
Would you like to, because just now you went to the toilet, right? Would you like
Yeah.
to start again? Okay, right. Can I test you a bit?
Okay.
Now, notice that in the first question, WXYZ, they intentionally hide the name of the metals from you, right?
Oh, wait, you
Let's
mean
say,
that question? I thought you meant the math. Okay.
yeah, no,
Yeah.
I meant chemistry. So they don't tell you it's Mg la or sodium la or Fe. Why? Because you already have it memorized. If they show
Mm-hmm.
you, certainly you will recall it and answer the question. And that
Mm-hmm.
is never what they want. They want you to think about it. Therefore, they hide the metal's name or they give you new metals that you have never memorized before. And that is by intent or by design. So far, so good?
Yeah.
Okay, so now I'm going to test you by saying, okay, what is the order, right? By giving you a reaction or a non-reaction, correct?
Yes.
So A plus B plus, right? Which is
Uh-huh.
the metals are hidden, and therefore they tell you B must be a B plus because there's no way for you to know. They must tell you, okay? And they
Mm-hmm.
say this is a reaction. Something will happen.
Mm-hmm.
You can already predict what will happen, right? You can predict that B plus will become B, correct or not?
Yeah.
And A will become A whatever
Okay.
plus. Maybe he tell you A is A2 plus, and that's their job to tell you. So
Uh,
the question is, what is the order? Can you immediately do it?
um,
Like who is on top and who is on bottom?
B is on top.
Okay, and then I'll write down for you. Okay, to prove it, we must use the mirror image thingy, easier, right?
Okay.
So let's say B on top, A on here. Does it look right? So
Yeah.
therefore, your A2 plus is here and your B plus is here.
Yeah. Yeah.
So in this case, this reaction says B2 plus becomes B and A becomes A2 plus, correct?
Yes.
Look at that. The jump up is bigger than the jump down. Look at that. Does that make
Mm-hmm.
sense? How can
No.
yeah, therefore, this is wrong. How can this be a reaction? The jump up is bigger than the jump down. How can it?
Wait. I'm a bit confused.
Mhm.
Wait, why do you put B plus under A2 plus?
Mirror image.
Oh, mirror
Mirror
image.
image.
Okay.
Mirror image.
Wait, I'm so confused now.
No, you're not. You just have to work out two options.
Okay.
A and then AB. There's only two options,
Uh, okay.
right? You're not actually I don't expect all my students to think about it. I expect all my students just say, okay, I'm gonna give it a try, okay? This is
Okay.
gonna be A plus and this is gonna be B2 plus B plus A2 plus. The other way is a little bit different, just like that. B plus and A2 plus, correct?
Uh-huh.
No, that's it. And then what do? You just see
Mm-hmm.
who is correct lah, right? B2 plus
Mm-hmm.
B. That this one is the first scenario. The second scenario would be this one. There. Which one is the correct scenario lah?
Oh, so you literally just connect like originally what was and like to the other one, and then you just see up or down which one is bigger. Oh, okay, that makes
Yeah.
sense.
And this one makes sense. This one does not lah, right?
Uh-huh. Yeah.
So therefore, A must be on top of B, or A is more reactive than B. Must be.
Okay.
Okay, makes sense. That is all anybody needs to do.
Hello.
Yes,
Okay.
Nicholas. All right, you're back.
Sorry, I was going.
Right. So now, Ariel, now a test for you, yeah. There is no reaction. It's a symbol
Uh,
of no reaction.
okay.
Then how does the order work lah? Understand? Okay,
Yeah.
back to you, Nicholas. All right. So Nicholas, you have this choice, and I like this choice. Okay. Shall I revise for you immediately?
Revise.
Yeah, revise in this case, is a differentiation lah, not
Okay.
Okay. So listen to me. I simplify it very easily. There's a basic differentiation. Do you remember this one lah? 3x power 4, right? If I differentiate that, the first thing I do is to write down what stays. What is it? What stays? The same? It's a
The
memorization.
3x
3x. 3x stays the same. It's a memorization. Very good. And then the second thing is the power change. What is it?
to 3
Into 3. And then the third thing is times
4.
4. And we don't care that it's 12. It's better to see as 4 times 3x. It is really better. Understand? Okay, that's the basic. And then you have 3 exceptions, right? 3 exceptions. And you have 3 rules. Okay, the 3 exceptions are sine, cosine, minus cosine. You don't need it here, right? And also e to the power x, e to the power x. You also do not need it today, right? And then last one is ln x and then become x power minus 1. You also probably don't need it here. I don't think so lah.
Okay.
So, but do you need the 3 rules? What are they? The rules for times, the rules for divide, and the rules for nesting or inside outside.
Nesting.
Okay. So which one do you need? Because this doesn't look much basic. You probably need one of the rules. What are they? Which one do you need, you think? Okay, I have finished the revision. If you want to know the rules, u prime v minus up prime, and I'll tell you like.
Oh, you mean that? Okay.
I mean, but the question is whether you need the rules or not. Now, Nicholas, stop touching your mouse. What's the point? What is the point of touching your mouse? Get a paper. When you don't get a paper, when I have to tell you to get a paper, I know you're just not ready, you know. You want to do this, right?
Okay, wait.
I know I'm just talking to Stone, so I'll wait until you're ready, okay? Ariel, have you decided who is on top and who is on the bottom?
I think B is on top.
Okay, and how do you confirm that you're correct?
I don't have no clue.
Hey, Ariel, I'm also talking to Stone. I asked you to do this. Did
No,
you
I
do
know,
it?
but how am I supposed to do that if there's no reaction?
Well, pretend is a plus and pretend is a plus lah. That's it, what?
Huh? I'm so
Just
confused.
pretend the one at the bottom is always a plus. Who
Okay.
cares how many plus does it have, Ariel? You have to
Okay.
overcome that because that's what they will do to you.
Oh, okay.
Okay, and then draw the arrows. So tell me what arrows to draw.
Draw A down,
Okay, and then
B up. Yeah, so
right.
it's
Yeah.
still.
Hey,
Sure.
it works, right? It works thinking like this. Yay, it doesn't work. Yay, yay, yay. I'm correct.
Uh-huh.
Okay, get it?
Wait. So what was it again? The down must always be bigger.
Like down requires no effort. You just jump down, man. Going up requires effort. So the jumping down in reality will give energy to the jumping up. The jumping up energy comes from the jumping down now. That's why the jumping down must always be bigger than the jumping up. If not, how can the
Okay.
jumping up happen? Because the jumping up, as you know in real life, requires effort.
Okay.
The effort must come from somewhere. Good? Okay. Now, just continue again. So you're ready to use this logic lah, right? So they tell you weird metals, the same thing lah. CD plus, tungsten 2 plus becomes tungsten metal plus CD3 plus.
Okay.
Order please. Now, Nicholas, are you ready?
Yeah.
Right. All right. So again, I've reviewed to you 3 things like basic, 3 exceptions, which you probably don't need, and 3 rules, maybe you do need, maybe.
Okay.
I always suggest that you start from the rules.
But like, whoa, go.
Go ahead, Nicholas.
You.
Ariel, do you have an answer?
Wait. I'm still kinda thinking.
Yeah, think, but please write down. Don't
Okay,
think too
I'm
much.
writing.
Yeah, write down, okay? I'm teaching you to write down.
I
Nicholas, you also. What is it? What is the problem according to you?
uh cadmium is more reactive.
So on
I mean,
top,
it's above, it's on top. Yeah. I
so
already
that
con
will be
I,
so plus,
yeah.
no problem. So in this case, cadmium will drop down,
Yeah.
and that is a very good thing.
Yeah.
Teacher,
Good area.
Oh wait, this makes so much sense. Why didn't my
Right.
teacher say this? Okay.
what teacher
Do
did?
something else. Do something else, and reactive series, find longer questions, Ariel. Okay?
Okay.
Okay, at least do one more. Yes, Nicholas.
You want me to memorize the 3 rules, right? Like,
No, I will give them to you. I want you to choose which rule applies here. That has always been what I'm asking you to do. What is important is to know, is there any rule that applies here?
no.
Okay, you have a problem.
Wait, what? What rule?
Then do it normally. Then the challenge is, can you do it without the rule? Because if your mind think, hey, I don't need any rule. Okay, then do it normally. Then do it like. You must also show it to yourself. Hey, I can what? Go.
Wait, no. But teacher, can I ask, right? The
Yes.
EX rule, does that mean that if a constant E,
The constant E, yes, the natural number lah, kind of thing.
the constant E,
Yeah.
if it's X with the power of X, it just won't change. That's what you mean.
Something like that. Yes. Only if it is the power X lah.
I don't even is it the times rule?
Yes, you will be correct.
Oh,
And now I give you the times rule. I give you the times rule. U prime
is it
V
times
plus
and
U.
divide?
No need divide, I believe. That's the result. The result is a division, but
Sorry, teacher, what is CS again?
which one? Sorry, which one?
The bracket.
Oh, that's the chain rule, the inside outside thingy. The inside outside thingy. If you think you need chain rule, you tell me also lah. I'll give it to you also. Inside outside. But a product rule is a good place to start. Now, please do your product rule.
I don't remember.
Look, who is U and U is V? In the situation here lah.
Wait, that's the product rule.
The product rule is this one lah. But I teach you how to use product rule. How to use product rule is
Isn't that UV prime plus U? Isn't it like something else?
hey, don't debate on this. Is UV prime plus U prime V plus
No,
UV
I'm
prime.
not trying to debate. I'm trying to remember. Like,
It's U prime V plus UV prime.
I thought that was used for like everything.
Nicholas, can we focus on the question, please? For now, the more you ask, the less time we have. You're still not doing anything, You're still not lifting
very
your hand and
confused.
doing it, You're
I'm
still
very
not doing it.
confused.
Yeah, so I'm teaching you again. Who is the U and who is the V? If it's a product, that means there is
Wait,
something
you're
times
talking about KX.
Yes, I'm talking about this thing. Yes.
Wait, I was talking about AK bracket X plus B. I said product rule. I don't know how this will be product rule.
Hey, Nicholas, why are you talking about this? This is the answer, Why are you talking about the answer?
Wait. Oh my gosh.
Why are you not reading the question? Yeah? Now that would be a bit frustrating.
I thought you already had the full question there. The equation KX to X plus 3.
Ariel, have you found another reactivity series question?
Oh yeah,
okay.
I sent
Teacher.
it to you.
Okay, good. Yes, Nicholas?
Now, may I ask why would this be a product rule?
Because to me, it is something times something. Is that simple? It's really.
But what is something that?
something times something. There you go.
They're not together. I thought it would be like 5 square root 5, like kind of thing. That's just wait. Let me check.
So Ariel, this
Wait,
thing
teacher.
is combined with something else, ma. You do not know
Huh?
what's extraction. You do not know what's blast
Okay.
transfer. It is a subtopic of
Oh,
the activity, and that one has not been taught yet.
okay.
That's all.
What is the answer? Correct. I
It's a
think
Uh,
it is, probably.
UKX.
Ariel, if you could, you check the answer key, but I will check for you also.
Okay, I will.
Nicholas, you're saying?
The UKX.
U is KX. Wonderful. Yes, U is I guess the first guy, lah, right? That's the first guy. Okay. And then I guess V is the second guy, I suppose, lah, right?
Yeah.
Then your job is to find U prime and V prime before we do anything else, lah.
How does product rule work again?
The product rule is just assembling this.
Oh,
You need the U prime and you need the V prime. That's why.
yeah, the answer is correct.
Good, Ariel. And you can see that some part of paper 2, if it's a reactivity series question, is very similar to the MCQ one. That's why I say
Yeah.
it's essential. The rest are you're just lacking the knowledge. I haven't teach you, and hopefully you'll see later that's the easier part lah. That's not the harder part. The one that you're
Okay.
missing. What is this extraction? Actually, that's more knowledge rather than logic.
Okay.
Do one more if possible. Okay, and then you'll be hopefully readier for your reactivity series. Nicholas, are we going to do anything, or are
I
you
don't
gonna
remember
ask?
how this works.
Okay, now are you confused with KX?
I'm confused. Yeah. I don't know.
Now, let me give you 5x lah, before doing KX.
Wait, do I do an open-ended or MCQ? Because all of the open-ended is combined with some other topic.
Correct, Ariel, and I want you to have that impression.
Huh, okay.
Okay, I want you to know, okay, reactive series is not going to be a pure topic. Chemistry is always a link subject. Have a look. That's the point. Or have a look, oh, this thing or that thing. Don't look at it 1 week before exam. You know what I'm saying? Look at it right
Yeah.
now. Right? That's all. So, what's the differentiation of 5x, Nicholas?
Uh, Wait. Let me remember. It should be
Now, this is the
5.
weird part. That's the differential of this 5x is simplified. Can you accept that?
Yeah.
So, the differential of kx is?
Okay.
That's it. That. Can you accept that?
Okay.
Okay, now this thing. Now this thing is only complicated because maybe you didn't think of it this way. I strongly suggest you think of it as like that. This seems easier for most people lah. Okay? We have 2
How
minutes.
does the +3 work?
+3 works. Well, let me put it another way. first. If you find that difficult, then try doing this first. Can you
That
do
would
this?
just be
Can you do this? Can you differentiate
that
this?
would just be 2 bracket half.
And that would be totally wrong because you miss applying chain rule. You need to apply chain rule here. That's your mistake. You need to apply for chain rule here, right? Applying chain rule, the inside stays the
Remember how.
same. This becomes minus half, and this is your half. So I'm doing normally, right?
Accurately, it's always -1, right?
No, it's like that. It looks like this.
No. Like the power always has to decrease by 1.
Yes. That's the
That's
nice
why
thing
the
about it.
half makes it -half.
Correct. That's the nice thing, right? That's very nice. You don't care, just -1 lah. We good?
Yeah.
Now this is
So
me applying the chain
2x
rule.
times 2. What 2 come from?
Hey, there's a power half here, you know. Power half here, power minus half here, you cannot ignore, you know.
Yeah.
Right? There's a half here and there's a times 2 here. Like. They both cancel each other if you like.
No, why is that times 2 in the first place?
Chain rule. That's the chain rule. You times the differentiation of the inside.
So the differentiation is like normal differentiation. So 2x will become 2. So it's times 2.
Yes, correct. Correct.
So if it was 2x power 2, it will be
Let's say
4x.
2x power 2, right? So then using chain rule, the inside stays the same, right? So 1, and then times 2. Remember the inside stays the same, and then times the differentiation inside. Times 2 lah. It actually
No,
becomes
as in like
x.
2x 2, no bracket.
Oh, 2x2 is basic stuff. Why are you asking about
No,
that?
as in just imagine that same sum 2x half,
Yeah.
but like put 2 instead of 2x only.
Like that. Yeah, correct. Okay. Correct.
Like you know bracket 2x.
Can you just
bracket
write down,
half.
Nicholas? Why are you communicating using words? This is pen. Why are you not writing stuff?
Like this one.
Okay.
That
Time is
would
up,
be
yeah. This is the last one, yeah. Time is up.
time is up.
Very nice. Yeah. Times 2. Yeah. Time is up. Times the chain rule, which the differentiation of the you must put the 2x squared inside first. The 2x, yeah. Okay. And then there is times 4x. Wonderful. You are absolutely correct. By writing is much clearer. Yes, wonderful. This is correct. This is wonderful.
So that would just be
Plus 3, plus 3, plus 3, plus 3. Hello. You need the plus 3. Remember, it's this guy. Ariel, have you seen a few reactivity series
plus
questions?
3. Wait.
Yeah,
Teacher,
I'm trying.
Good. When you're
Teacher.
trying, whether you're successful or not, remember, you are ahead of class. That's what we're aiming for. And you're surveying exam level questions. That's what we're aiming for. Good for you. Okay? And whenever you want, right? And whenever.
Teacher.
Yes.
If I correctly, the 3 doesn't change at all, right? If there's no x on it,
No.
it just means it doesn't
2x
affect it.
plus 3 lah. Yeah, the inside must always stays the same. 2x plus 3. Yeah. Power minus half. Hey, power minus half. Hey. Good. And then time. Yeah, correct.
So if I correctly, since even no. If the inside is just 3, no x anything, you don't have to think about it at all.
If the inside is 3 and there is no x, right? If there is no x, there is no question. If there is no x, there is no technique needed. The whole problem is that there is an x.
No,
If
like
there is no
you
x
see 2x
inside,
plus 3, right? That one, the 3 does nothing. It's like you only put times 2 there because of the 2x. You do half because of the half over there. But the 3 just like it doesn't change
but
anything.
that's because the differentiation of 3 is 0. That's just because of that, right? You actually did differentiate the 3 and it doesn't make an impact. That's all.
Oh yeah. No,
Okay, you must remember that.
a normal constant differentiator is 0.
Correct. And so it does not make an impact, but you still have to think about it lah. You just have to think about it. Oh yeah, okay lah, it's nothing.
Okay.
It's not that you can ignore it. No, that's not exactly.
You know what, just for the sake of it, it'll be like this, right?
With something like For the sake of it, you are right. This is thinking about it. You're thinking, I like it. Yeah, good. And I think your teacher will be teaching the 3 differentiate into 0. Maybe the first thing tomorrow, either. Maybe that's the first thing. Okay, and you're already at the very good position to solve this lah, but we'll continue next week. Okay?
Okay.
No, next time, like Wednesday. All right?
Thank you.
All right, see you then. Bye.
Bye.
Son, I can see you. Sorry for the delay. Can you hear me?
Yes.
Okay, Son, you can see my screen, yeah?
Yeah.
I'll take some updates first if you don't mind. All right. So, Son, you have told me that the iPad is now stricter, right? Yeah, I understand.
Yeah.
You're also telling me that the iPad has no Zoom, correct?
Yeah.
Because most schools are experiencing this lah, but strangely, one of the school can do Zoom, but other schools cannot lah. So I'm just taking note. Zoom, you do have other devices, right? Am I correct?
Yeah, I'm using my phone.
Okay, you have a phone, which you have Zoom, and you have a laptop also. Is that correct?
Yeah, but it's like not with me now.
Why is that so? Sorry, tell me.
I don't know. I don't use it. It's like somewhere else. I mean, it's in the house, but not right here.
Okay, your laptop is not a part of your usual study
No.
environment. Okay, understand. You do have a laptop, but it is your laptop, is not a shared laptop.
It's shared. Like I think my
Oh.
sister.
Wait, brother, sister, something like that?
Yeah,
Okay, a laptop is shared. You only share it with your sister.
I think so. I don't really
Mm.
use it. Like I've never used it.
She uses it more.
Yeah.
Okay. Okay. Sorry, this is important. She's in what secondary?
2.
Slightly busy already. Okay, understand. Okay. So that's the upgrade. The update with the iPad. Your good notes are still good notes 6, correct?
I don't have good notes anymore.
Oh. You don't have good notes anymore.
Like I don't have any apps. Like it's like resetted, so all my apps were deleted.
You have Google Drive, you have Google Classroom, but that's it lah.
I don't have Google. I don't have any of those. I use the web version because they haven't like downloaded it onto the iPad yet.
So wait. Back. You will have good notes sooner or later.
I don't know about GoodNotes because Google Classroom is like before, like it always was there, but then GoodNotes like I downloaded myself, so I don't think they're gonna like download it back.
Okay, let me confirm one more thing. So this iPad is from your school, right?
Mm-hmm.
But if there is no good notes, there is no writing app, right? Then does that usually like, even last year, if you don't download good notes, you don't have a standard writing app, right? In your iPad.
I mean, I just use the Notes app, but like I don't really like using it because it's very limiting.
Correct. I also don't like it at all now, which means that most people won't like it if they're using it seriously lah. Correct or not?
Yes.
Does that mean that your class itself doesn't actually ask you to use the iPad?
Not right now, but
No, last
I
week,
mean,
last year.
or like last year they do use like some classes.
So in those classes that uses, what is the app that they prefer to use for
I
writing?
mean, normally we don't use for notes. Like they'll give us files, like or like online worksheet. Then we write like we do notes on those online worksheets.
The online worksheet, browser-based, something like that, right?
Yeah,
Browser-based.
like PDF.
Oh, you have a PDF app which allows you to write on the PDF lah.
Yeah, files.
The files, really? The files,
Mm-hmm.
the files native app can allow you to write on the PDF.
Yeah.
Oh, and you just submit that lah.
Yeah.
And the class is very happy with that.
I mean, I guess like no
Except that
opinion.
you cannot write notes lah. Basically, you're just very limited lah. Except lah.
Yeah,
It's a very sad situation. I don't understand.
I know, right?
iPad is a very big investment, I don't get it. I just don't get it. Any other restrictions this time?
Not really. I mean, there's like really nothing on my iPad right now. Like there's just Safari and the Notes app.
Right. So in all, right now, is a downgrade from last year.
Yes.
Did you lose anything important to yourself?
I mean like I lost the GoodNote stuff because apparently like it needs to be backed up into the iCloud. But like
It
there
does.
was like some weird issue with my iCloud because I was using the old school iCloud and they resetted the school iCloud, like the Apple ID that the school gave. So like all the stuff in mine was like gone, including the GoodNotes. So like even when I sign in on GoodNotes, like on other devices, it's not there because
Alright.
it's like back in the iCloud.
It is never back into a proper iCloud, right? In your personal iCloud. Now,
Yeah.
it's okay for losing the holiday notes, good note. That one easily recoverable. But your own good notes from Sec 3, other subjects, everything did you lose all of them?
I never like used GoodNotes in school before until like the start of this year. So like I just lost like very little notes like from school.
Okay,
Like
so personally, you're okay lah.
yeah.
Okay, good. So I'll call it no real loss in content.
Okay.
Okay, correct, yeah? That is still the case lah. No real content loss. Whatever content we do, in holiday tuition, they are all designed to help you think, and they are very easily replicated. Okay, that one is not a problem now.
Mm.
Okay, that's the iPad situation. So at the very least, I need updates for your Chem, A Math, and WA1 if there is.
Chemistry, like my teacher like very, very briefly went through the periodic table. Like she did it in like really quickly. And then apparently chapter 22 is self-study chapter. So
What is
like
that? What is that?
22 is air quality.
Pollution, really? Wow, pollution is important.
Yeah.
Okay,
So like we didn't really, she just gave us a class quiz. That's all.
sure.
And then we started on electrolysis.
Mhm.
And for A math, we finished up trigo, then we learned binomials, and now we like just started differentiation, and we're like on the chain rule now.
Oh, speeding through, isn't it?
I think so, I don't know.
Let me confirm chemistry. So in the 2 weeks, right? In 2 weeks, you briefly went through periodic table and pollution, or rather self-study, whatever.
Yeah.
That is the 2 weeks.
And like actually no, I think like the first week was the 2 chapters, and then like last week we started electrolysis.
Oh, last week you already start electrolysis. Okay.
Yeah.
Speeding through. Not necessarily good. Now you already 1 week in electrolysis. Tell me about electrolysis. Is it already in the battery? They call it the cell.
No, we like started like with the very basics. Like we're not that deep in yet also. Like
So
we're just
it's slowing
learning
down.
like yeah.
It's slowing down. Okay, it's slowing down.
Yeah.
Okay. So you are you at the dilute concentrated situation?
I don't think so.
You are at molten situation.
Yeah, we're like at the part where we're still learning like the anode and cathode stuff.
That's too much of a slowdown.
Oh.
That's just not. Never mind. Okay, I understand. So you're in a very starting part. Okay, great. I'll tell you the implications later. Now, no practicals, right?
Oh, my WA1 is a practical. Like it's gonna be.
Okay, in what topic?
I don't know, they haven't confirmed it yet.
Okay, WA1 is practical. Can we confirm a few things about the past topics? Have you done reactivity series
Um,
last year?
is that chapter 13? I think so. I think we did. Actually, I'm not sure. I don't have my textbook right now.
Okay, in electronic, oh, your electronics is so early. Okay. I'll just show you something. In reactivity series, you have reactivity series, and they will ask you to memorize, and you need, and I teach everybody how to simply memorize it, right? This looks like an order of metals. So you have A and A, Ca, Mg, and then Al. Right? You have zinc, Fe, Pb, and you have Cu, Ag, Aga. Have you seen this series before?
I don't think so. I mean, there was like a page on the textbook that seems familiar, but I don't think we did reactivity series.
Yeah, that worries me, right? Confusing. Probably not. Okay, then how about speed of reaction or rate of reaction?
I don't know. It doesn't really sound familiar,
Yeah.
but I'm not sure.
How about um how about endothermic, exothermic, energetics, enthalpy?
No, I have no idea what that is.
But you did your mole and you did your acid and base.
Yeah.
Okay. Okay, understand. Very weird. Some schools do weird things that I don't understand. Okay. Understand. Now A math. You're saying that right now you are starting differentiation.
Yeah, like we started a while back.
how many days or 1 week already, maybe?
Yeah, I think so.
I promise you and everybody else, when you start differentiation and integration, you will feel like you have done it before, basically, because of holiday tuition.
Yes.
Right? Did it happen that way?
Yes.
You are now, well, I think your AMAT before is not that bad, but right now you should feel even more in control.
Mm-hmm.
Now, I don't know you. I don't know your personality, son. So I'm making a guess, and I need you to tell me whether I'm right. Okay. You seem to me the type that if you feel you can do it, you will not actually slack. You will be motivated to do it even more lah.
Oh yeah, like for math.
For math, for differentiation lah in this case. Hey, I can do it. Let's go, man. Something like that.
Yeah.
You know, there are other people. Hey, I can do it lah. You know, something like that. Okay. So you are not that type. Correct?
Yeah, I think so.
I hope so. But it does feel like you're like that. Sorry. I have to message one guy and just to make sure that he's okay. Because we cannot lose too many sessions today. Wait, let me just. Okay, done. In the 1 week, what happened? Sorry, Amen. Tell me again.
Like we finished up Trigo on like the first or second day, then we did binomials like really quickly.
You need binomials in half a week.
But not half a week, like no, we did some of it during the CAP program in the holiday. Like we started with the basics and then yeah, we did binomials for like a week.
So are you saying that your Trigo, you already did a lot before the holidays?
Yeah.
You're just finishing up there. Wow. You
Yeah.
were doing the R formula, I guess?
Yeah.
Wow. And you feel okay. You feel okay with this kind of speed.
I think so. Like it's manageable, but like I need to recap Trigo every now and then.
Of course. Your binomial also. You okay?
I mean, I think so. Like it doesn't seem that hard, but like I don't know.
Well, okay. Can I quote a few topics just to make sure that you have or have not learned? Okay. Linear law
Um,
or graph of linear whatever. You have to draw things. You have to draw a straight line, and you have to you do have weird stuff. Y mx plus c.
I mean, is that the Sec 3 topic?
Well, I'm asking you whether it is in Sec 3. Some is, some isn't.
I think it is. I think I did it. Yeah.
Okay. So linear law is done. Circle coordinate geometry, not the normal one.
Yeah, that
Okay.
one I did.
Wow, your AMAT is very fast.
Yeah.
So it is, remind me again, back then when we first met, your main concern is chemistry lah.
Yeah.
Not AMAT, right? Your AMAT is quite in control lah, something like that.
Yeah, I think so.
Okay, I understand. Good, that's it. Okay. So let's say today, right? Today, oh, Sean, right? We never actually did a norm. Did we ever did a like a normal week, school day session before holiday tuition?
Yeah, like before end of year.
Oh, it's right straight before the exam. Okay, right.
Oh yeah.
Yeah. Okay, that's when we meet, right? Okay. Right. Now, today you seem quite relaxed lah. Am I correct?
I think so.
Right. You don't have questions for Emma?
Not really. I
Okay.
don't know.
Don't worry. If that's the case, then I will ask you questions. Oh, no. But we have time to plan, you see. Do you have questions for chemistry first? You want to clarify anything first?
For chemistry, like I haven't started like like studying, like self-studying. So like the stuff in my brain that I have right now from chemistry is like all in class. So it's like a bit jumbled. So it's like not organized yet.
You're just talking about electrolysis, or you're talking about the last two things also?
Yeah, like I mean air quality I study already, but the periodic table and electrolysis.
Okay, I understand. We'll do something about that. That's the plan anyway. Good. And then I'll give you an overview of for lah now that we are really in. Will that be okay?
Okay.
Uh, Tell me a few more. I kind of forget. I've never passed you a phone holder. Have I? Did you?
Oh no, you did. I have one.
Did we use it last year? The phone holder.
Yeah.
Okay, it's still there. Okay, good. Today, no worries. Okay, now you give me a time to go to the toilet, just a little bit. Okay.
Okay.
Eben, I can see you. Yeah, let me go to the washroom for you. Hey, Eben, can you hear me? Eben, can you hear me?
Yeah.
Okay, a bit soft. Let me just increase that. Okay, testing again. Eben, can you hear me?
Yeah.
Okay, cool. Now, so give me 2 minutes with Eben first, yeah? Eben, how are you right now?
Um, I just woke up. I forgot to wake up at 7:30 just now.
No problem. This means that you are tired, right?
Yeah.
Tell me. Oh, sorry. Have you even had dinner?
Uh,
No. No, right?
no, yeah.
Go and get dinner first, okay?
Okay.
Go and get dinner. Just stay with us, but eat your dinner, okay? Okay.
Okay.
Tell me when you come back, right? When you come back. Okay, good. Now back to you, Sir, right? I will show you the big picture of the electrolysis chapter so that you feel, well, you feel that the class is, you know where the class is going and you know what to focus on, okay? This is the same effect as holiday tuition. I'm showing you something before it happens. And then the details you will fill in yourself because you're the type that is motivated when you feel you understand it. Something like that?
Yeah.
Okay. So now, let's be very clear, yeah? Let's be very clear. The purpose of the purpose, okay? I'll tell you straightforward the practical considerations. Electrolysis chapter is the hardest one because it combines a lot of the concepts. A lot. It combines mole. It combines acid and base sometimes. It combines redox. It combines your sec3 metals, and ions. There's so many things that goes into the electrolysis, plus is in a very new package somewhat. So it is a good test of whether you understand or don't understand certain many things. The reward of doing electrolysis well is that you feel that your chemistry in general is very strong, very solid. Okay, so because it uses a lot of the past concepts. Okay, but it takes a long time to figure it out. Takes a long time. I'll just say it that way. It takes a long time. It takes even longer than organic chemistry to get right for a very small portion of the exam. Electrolysis has a very small portion in the exam compared to the efforts that you put in. Okay, so that is the reality right now. So it looks like your teacher will be spending quite a lot of time in electrolysis because even teaching it seems complicated. Okay, which for some strange reason in O level, I don't mean in your prelim, I don't mean in your WA1, don't mean that. In prelim and sorry, in O level, it occupies a very small portion. I don't know why they designed it that way. For a lot of effort, you only are doing a very few marks. That is the practical side of things. You okay with me?
Yes.
Now, my purpose in giving you an overview is so that there is a second practical problem with this chapter. They spend a lot of time in electrolysis, which looks like this. And sometimes, to my surprise, they went past through the counterpart. The counterpart looks like that, very similar. They just breeze through this guy and guess who is more prominent in O-level exam.
The first one.
No, the second
Oh.
one. So they spent a lot of time in the first one. You spend a lot of time trying to understand it. It doesn't feature that much in O-level. And this guy, which they breeze through, I hope they don't do that to you, but they do that to some people. That guy features much more. The heck, I don't know why this happened. It's very frustrating when I think about it. So my purpose when giving this overview today is to prepare you to also understand this, because this is also the easier one, by the way. But there is a lot of confusion between them because they look very similar, such that when you see a question, your brain gets jumbled up. I am trying to prevent that from happening. You cannot ignore the chapter anyway. It has some benefits, but I want you to be able to see them as a whole and not be confused. And therefore, you're just more ready for exam. Are you okay with me?
Yes.
Okay, so let's do it. Evan, just checking if you're ready.
Yeah.
All right, good. Are you eating?
Yes.
Good. I'm trying to explain a chapter called electrolysis to Sean. We're at the starting point. Evan, you are probably not anywhere near in your chemistry class. What is your chemistry class doing right now?
She was doing a bit of, I think she was doing redox today.
Okay, Evan, as you eat, okay, and you're still tired and groggy, right? So you're recovering your strength. You're gonna follow this chapter with me, okay? You're gonna pretend that today is a continuation of the holiday tuition. In holiday tuition, we discuss totally new things regardless of the school's tempo, right?
Yeah.
And you don't seem to have any problem following it, correct or not?
Yeah.
Right now, you are a bit tired, so it's a disadvantage, but we're going to do the same because it is good for your final exam. It is good. Okay. I always hinted to you that your school's tempo is just too slow for anybody's good. It's not good at all. It's not good at all. So right now, you adjust to our tempo because like it or not, you will have to. If you adjust too late, you'll be too rushed at the end. And as a person, Evan, you really do not like feeling rushed. Correct not?
Yeah.
Okay. But you see holiday tuition, do you feel rushed?
No.
Okay. And that's what we're doing right now. We are trying to not rush you right now, we're trying to give you the benefit of an overview. And I'm also trying to prevent the inevitable rushing that your class will experience after July. It's inevitable at this point. Understand?
Okay.
That's the purpose. Now, follow me and both of you actively ask questions. And of course, I will also engage you for today. Eben and Sean, can?
Yes.
Yeah.
Eben and Sean, the chapter electrolysis has two components. Okay, the drawing should help. It's a very visual, by the way, it's a very visual chapter. The drawing needs to make sense. You need to draw it. So Sean and Eben, whether you're drawing on your own iPad for now, or whether you are drawing on a paper, draw, please. You don't master the drawing, nothing works. Okay, does somebody need time to get pen and paper?
No.
Yeah. Oh.
Okay, good. Eben, no, right? You okay, right, Eben?
Yeah, got it.
Okay, good. That's all. You just need a pen and a paper, and this is supposed to be inside your mind after today anyway. So you don't really care where you put it later. Both, whatever this both are, okay, I'll put it this way. This is like a power bank charging. And this is like a power bank being used. Okay, so you have a power bank.
Yes.
According to your own logic and thinking and understanding, is there a difference in the power bank, right? When the power bank is charging and when the power bank is being used.
Yes.
What is the difference according to you? Just your own words.
Like one is electricity going in, one is going out.
Very good. I agree with you. Now, in this case, which one is electricity going in?
The one used. No, the one charging.
Very good, very good. And you're thinking, electricity going in, electricity going out, right? Right? Okay.
Yes.
Now, furthermore, if electricity is going in, and this is electricity energy. Now, you are all both learning science, you see. So inevitably, you have to consider this. If an electricity energy is going in, what does it become? Now, this is a more technical answer. So, do you know what it becomes?
No.
Okay, Evan, any idea?
Electrical in. Oh.
Correct. Power by charging, electrical energy going in. That's called charging, correct?
Yeah.
What does it become?
A battery.
It becomes a battery. You're right. Battery has what energy?
Uh, electrical.
So it doesn't make sense, right? Electrical energy going in, basically what you're saying is that when electrical energy in, it becomes battery, but battery is just electrical energy. So it's just electrical energy going in and being stored as electrical energy. That is what you're saying. Correct, Evan?
Yeah.
Something like that. Now, that is normal thinking for a person that does not study chemistry or physics. That is totally fine. A normal person should think like that. When I charge a battery, the battery is going to store the electrical energy. And that's it. That's all I need. But as a person who learns chemistry or science, you are, I suppose, expected to think better and more. So you must not just know the answers, you must understand more than the, well, I suppose normal people think. I hope this is an acceptable expected result. Evidence, yeah? You need to know more than what a normal person thinks. Would that be okay? Okay, that is the expectation. Now, I will say this and hopefully this makes sense. Now, a battery stores chemical energy. That's how they phrase it. So electrical energy in and it becomes chemical energy. Would that be okay? Now, this one is electrical out. So where does it become? It comes from the chemical energy which was stored and out goes electricity. Okay, I'm saying a few things to you. I'm saying that electricity cannot be stored. Chemical energy can. So you're not storing electrical energy inside your power bank. Okay, because if it is, when the power bank just leaks, it will leak out thunder and electricity, and you will get shocked. Is that what happened when you cut open a power bank, sir?
No.
When you cut open power bank, you don't see a thunder inside and you don't see electrical inside. What is inside then? A very fully charged power bank.
Um,
You have seen it explode, right, in the videos?
no.
Do you know what's the reason that you cannot carry on power bank into the plane? Do you guys know that you cannot carry on power banks into the plane?
Really, I always bring it.
Well, I'm sorry. You cannot put it in the luggage. Sorry, you have to carry on. Sorry, you have to carry on. I get it. You cannot put a big power bank and a laptop, whatever, in your luggage, checking it in. You have to bring it in the carry-on. Sorry, do you understand what I'm saying?
Yes.
Yeah.
Do you know why?
Yeah.
Air
Oh, right.
pressure.
Try Evan first. Evan, why?
Can this can also you can like fire. There can be fire.
All right.
Yeah.
Now, if the power bank catches fire for whatever reason and is in the luggage compartment, what difference does it make if it catches fire in the passenger compartment? You understand, right, Evan? You're told to put your battery in the passenger compartment, not the luggage compartment below. Do you know what difference it makes, Evan?
I guess like down there it can overheat then like
You mean in the luggage compartment below it can overheat? No, it's actually very cold down there. Actually, when you fly up, the air up there is very cold. You don't feel it too much because you're not actually being air conditioned. You're being heated actually in the airplane. Actually. So no, below when all the big luggages are stored, that's very cold. If a person tries to stow away, do you know what's a stowaway, sir?
The on top thing.
But in a plane, you don't stow it on top, you die lah. Get fly away. You stow away in the luggage compartment where all the luggages are. Make sense? You just don't pay the air ticket and just hide there lah, okay? Hoping to ride the plane for free. Make sense?
Yes.
When that happens, most people usually die because it's cold, number one. Two, the atmosphere is very thin. You cannot breathe. Anyway, it's not a nice place to be. Back to the question of power banks, okay? If a power bank catches fire in that luggage compartment, what difference does it make compared to if it catches fire in your compartment? Any idea? Evan? Okay. It's a very practical consideration, okay? It's a very practical consideration. The rule makes sense. The fire from a power bank, modern power banks, confirm cannot be put out one. If it burns, it will burn continually. The fire itself is rather intense. It's not that bad. It won't explode, but it will continue burning. In the luggage compartment, there are many things to burn. Make sense? Correct? Once something is burned, no matter how cold it is, things will burn. Either there or there, clothings and whatever. And that fire cannot be put out. I don't need to tell you that when there's a fire that cannot be put out in a plane, people may die, right? On top, if something catches fire in your hand, people can react, throw that power bank out at the risk of burning, but you can possibly do that. It's easier because the fire cannot be put out. You cannot spray it with water. You cannot spray it with, I don't know, the fire extinguisher. You have to actually take it and throw it out of airplane. Let's just say that the air stewardess know how to do that lah, because they have to do that. Okay? Right? So the only reason they want you to bring your power banks, back then power banks can be dangerous, or your big laptops onto the passenger compartment. If something happens, they can take it and throw it away before it is too late. Basically outside the airplane. Okay? In the luggage compartment, it's probably too late. Would that be okay?
Yes.
Yeah.
Now, what does that have to do with all this discussion? Well, to convince you that power banks do not store energy as electricity. It is putting out fire. So does it store energy as heat? Also no. If not, it will feel actually extremely hot. It just feels moderately hot. When you puncture it, chemical energy or chemical reaction happens. Chemical energy or chemical reaction happens. So that's why we say it is a chemical energy, because it is very violent chemical reaction happening inside the power bank. Okay, clear? Okay. Power banks store energy as chemical energy. When the power bank is being used, believe it or not, the same reaction, which is supposed to be very violent if it is punctured, is very controlled when we do it. It just goes slowly, and it is slowly being used to regenerate the electricity. Okay, at this point, Sean, does this sound complicated?
It's manageable.
Good, because that's exactly what you're learning in this chapter, whether we know it or not. Exactly that. Hey, when electricity come in here, what kind of chemical reaction happen to store energy? Hey, when I'm using the power bank, hey, what kind of chemical reaction is happening to give out the electricity? That is the essence of this chapter. Eben and Sean, unclear?
Yes.
Ask your questions right now. Clear? Okay, good. Now, you might not think that a chemical reaction can produce electrical energy. You may not think that way. Now your thinking is about to change, right? The difference between the left one, power bank charging, and the right one is that in the power bank charging, you have a source of electricity. They represent it as a battery lah, but it can be anything lah. It can be your PowerPoint and everything. This is a source of electricity. In the right hand side, well, you don't have a battery. That makes sense? Because this is being a battery. I hope that makes sense. In the left one, a bigger battery is charging this empty battery. On the right hand side, you are becoming a battery yourself. Okay. So they put a voltmeter, okay, over here for you physics student. You recognize a voltmeter. Certain you will recognize this as maybe, I don't know, you probably recognize this from primary 6 lah, but you call this something new. They put a voltmeter here to represent anything that a power bank can be plugged into. So Certain, what do you use your power bank for?
To charge my phone.
Right. So this voltmeter, for some reason, represents your phone, something like that. And then what do you use your power bank to charge?
I actually don't use power bank, but yeah, it will just be a phone. Yeah.
Right.
Okay.
Then maybe I guess it's a phone. Okay. Right. But that's good. Maybe less thing to carry lah. Now this voltmeter represents whatever is it you want to charge with your power bank lah. Okay, it sounds very weird, but they will never bother about the voltmeter, nor they will change it. So one more time, if you see a voltmeter, you know this is power bank being used. If you see a battery, so to speak, you know this is power bank charging. The technical term for this one is this is an electrolysis. This is your electrolysis. And this is not electrolysis. This is a cell, they call it. A cell is a technical term for a battery. All these names are confusing. You better remember it right now. So, if they call it an electrolysis, are they referring to the left or the right?
The left.
How do you know that they are talking about electrolysis based on the picture?
Cause like it's a battery.
No, it has a battery.
Oh, it has a battery.
Like doing stuff to this thing. Okay, this whatever thing is. Eben, how do you know that this is not electrolysis?
Which one?
Uh,
Oh,
Like there will be two types of things happening here. How do you know that it is not an electrolysis situation based on the picture?
Uh,
When
yeah,
there's no battery.
no, oh, okay.
When there is no battery on top, when you see a voltmeter, like, wait, that's not a battery. That is not an electrolysis happening. So
Okay,
therefore, this is a power bank being used. Okay? That you
okay,
okay? You need to tell this immediately from the start. The thinking is slightly different. So, can happen?
okay.
Okay. Now, other than that, the drawing is very similar. That contributes to the confusion. The drawing still has we'll call this a cathode and anode. Okay, we don't care about that right now. And you also have a liquidy thing here called the electrolyte. Again, the naming doesn't matter. What matters is you know what they are for. Look at the picture. The picture is like that. And the picture is very similar. Okay, this is not designed to fool you. The fact is they are both power banks, man. If you think about it, a power bank is a power bank, man. What matters is what you plug it with. If you're plugging it into a power source, you are charging it. If you're plugging it into some sort of devices, you're using it. The power bank itself stays the same. Therefore, the drawing stays the same. I hope that at least makes some sense. Can Sean?
Yes.
Can Eben?
Yeah,
One more time, the thing inside the power bank, you are not supposed to expect to change. But what you plug it with will determine what it is doing. So you pay attention to the thing they are plugging it to first. I hope that makes some sense, yeah? Yeah. Then secondly, they will ask you, so what's the difference besides the thing you're plugging into? If I plug in a battery here, what happens inside? And that is what they will ask you. If I plug in a device represented by a voltmeter, so what will happen? They will also ask you. What happens is always in terms of what's the reaction. What is the reaction? That is what they will ask you. If you get this by today, then good for you. Okay, Ken? That is the purpose for today. Right? Now, back to it. Any questions so far?
No.
Evan?
oh no.
Now, I purposely draw the battery on the right-hand side now. Previously, is on the left. Okay, so that you get used to thinking who is who, yeah? Now, for this one, this is your what you call the electrolysis. Okay, this is where electricity will go in. Now, immediately, Sean and Eben, the first thing that you do here, because the question will not tell you. Sometimes the teacher do not teach you as a first step. I teach you this as the first step, the most important step. You see a battery, you draw electron and electron. The electron will go like that. Do you understand, Eben and Sean?
Yeah,
Yeah.
If you do, please draw the electron flow. Then gonna erase it. Okay, easy peasy. Now I'm gonna erase it actually. I'm going to put a battery here like that. Okay, now, Eben, tell me, the electron flow is like that, or number one, or the electron flow is like that, number two.
One.
One.
Okay.
Now, if one is correct and two is wrong, therefore, how should the flow of electron here be, son? No electron at all?
The like same direction.
We must go into the battery source, okay?
Yes.
And this is very important. Now, this implies, people, that the reaction, where does the reaction happen? The reaction happens down here at the at the at the surface between this solid thing. Sorry, this is a solid. Sorry, this is a solid. And this is a liquid. It's an aqueous liquid usually. Okay, usually. And the reaction happens here. And this reaction is forced to accept an electron. And this reaction is forced to give off electron. Okay, you have never heard of a reaction that, accepts electron, maybe, I don't know, and maybe release electron. Maybe you have heard it, maybe you never. That is what's going to happen. So there will be two reactions here. First reaction is here. Second reaction is here. Any questions so far?
Is this experiment on water?
Very good question. You're questioning what is this, correct or not?
Yeah.
Now, most of the time, okay, battery cannot run on water. Most of the time. But this is not a battery. This is an electrolysis. And yes, this can be water. But it is a very bad thing. Most of the time, it is water plus, which you know as aqueous law. Now, I'll give you an example, Evan. It is water plus NaCl. Everybody knows NaCl. So it's salt water lah, basically. Correct or not?
Okay.
Now, salt water works fine. Salt water works fine as a liquid inside this electrolysis here, which basically means it will work fine here also. Remember, this is just power bank doing different situation. The inside can be the same one. If this is salt water, this one can also be salt water. Can I accept that? Okay, so far so good. Now, the requirement for this liquid is not that it is water. The requirement is that it conducts electricity. Do you know why, sir?
So the electron can flow past it.
Something like that, because the loop must close. Correct? The liquid must close the loop. And it must be a liquid, just saying. If this liquid cannot conduct, which in the water case, the water is a very bad conductor of electricity. Can lah, but very bad. So it's not a very good battery, no? Or it's not a very good power bank, no? You gotta use at least salt water lah. So because salt water can conduct electricity very well. I hope this makes sense. Okay, that's the main requirement of the liquid. Okay, but that's very physics. In chemistry, the liquid does determine the reaction also, right? So now I will be using a very strange liquid. Today, we're not going to talk about water and salt first. So I'm going to talk about the molten situation, okay? Okay, basically, Ben and Sean, I can put something else. I can melt NaCl. Melting NaCl, salt, requires 800 degree. Very high. Very, very high. Actually, I think it's higher than that. But I can melt it, and then this becomes a liquid NaCl. What does a liquid NaCl do? It automatically splits into Na plus Cl minus, both in liquid form. Is this confusing, Evan?
Yeah, can you go back to the melting part?
Okay, right. Now I'm referring to Sec 3. Okay, now let me ask Sean, did you remember in maybe term 2 Sec 3 very early when they say, oh, this is an ionic substance, NaCl is an ionic substance, right, Sean?
Yes.
An ionic substance can conduct electricity. What's the requirement?
Molten or aqueous state.
Good. So only two options lah. You either dissolve it in water, so the water can conduct, or you melt it. So Evan, this is what's happening. You have to give very high heat, but it will melt. Back to you, Sean. When NaCl melt, the secondary tree tells you it will become its positive and negative.
I don't know.
So both of you. A molten ionic substance can conduct electricity. Why? How did they phrase it, son?
Cause like the cause
You will have what? You will
the
have
electron charges.
no.
Oh.
You have mobile. I am so sorry. You have mobile charge. carriers, right? Very fancy words. Right? Have you used this phrasing? Have they taught you to use this phrasing before?
Yes.
This mobile charge carriers is your positive and negative ions, though. That's a low. Why is it mobile? Because when it melts, it can flow around now. That hot liquid molten salt is your flowing Na plus and Cl minus. They actually already tell you in Sec 3. Does this make some sense?
Yes.
Eben? Okay.
Yeah.
So one more time, when you melt the NaCl or whatever it is, it will become its positive and negative ions rather freely. That's the point. That's why it can conduct. Again, any questions here?
No.
Now, so it turns out the molten ions in this case plays a very important role in the reaction. In the end, this is chemistry. We need to, we have to understand the reaction. If that's what you are doing, you're on the right track. If you just memorize the reaction, you're off to a difficult journey lah, because you don't understand the thing behind it. Okay, now the preparation is done. You now have Na plus and Cl minus. What is the preparation? You're melting it. You're melting. Now, Sean, do you remember anything from your first week? What reaction will now happen?
Don't know.
Oh, you're not sure. At this point, you're not sure at all, Sean. You cannot immediately say, it must be that.
No, I remember writing like the half equation, but I don't know
Yeah.
what it's called.
You cannot pinpoint immediately whatever the half equation. What happens here? Cannot?
Like I know it's about the electrons.
Yeah, but and right now you cannot. You cannot say, it must be this thing and this is it.
I don't know. Is it like the chlorine or like no, the Na will like minus electron.
Minus electron.
A plus electron plus electron.
Electron. Thank you. Thank you. Very good. Very good. Very good. Now, Eben, again, Ari explained everything, so Sean also feels good. Remember, I told you the first thing is to consider the electron flow, right? Because of that, you now know this guy, this solid piece of don't know, right? Don't know what it is, but it's a solid piece of thing. This solid piece of thing is currently receiving electrons, so it feels very negative. Correct or not, Eben?
Yeah.
Something which is very negative will inevitably attract a positive thing. It will repel the negative thing. Make sense? That's what you learn from physics anyway. Okay? Okay. So this very solid receiving electron negative thing has Na plus all over. Na plus all over. And as Sean has suggested, okay, by the way, the Cl is being repelled, okay? As Sean suggested, because the electron is being forced down, there is no other way but for sodium plus to accept the electron. Now there's a reaction to accept electron. To some of you, this may look very new, but please understand, it's a very simple thing. The battery on top is forcing the electron down. There is nowhere else for the electron to go. Sodium plus is being attracted, so they are forced to combine. Ceplok. Can? Sean can?
Yes.
Then Eben, you're the new one. Tell me, sodium plus combined with electron, what does it become?
Uh,
Come on. It becomes?
just sodium.
Yeah, excellent. It becomes sodium metal.
Okay.
Okay, sounds too simple. It is simple. But you have to know that this is true, and you have to understand that this is correct. This is a sodium ion, a sodium metal, a sodium ion is different from sodium metal. So, this is what you're thinking, right?
Yeah.
Good. Now, your test is, so what happens on the other side? On the other side. There are two sides, right? There are two sides. There are two metals, whatever. So what happens here? Sorry? What happens here?
The chlorine loses electrons.
Because electron is being pulled out of this side. By who? By the battery, by the battery. So the Cl is being repelled, Cl is being repelled, and Cl will there go here, congregating here. So, I need to pull the electron from somewhere. So Cl will be my target, says the battery. Cl minus electron. Okay. Okay, sir, I know your teacher don't say this. I know, yeah. So Cl minus, take away an electron, will become Cl. Make some sense?
Yes.
You learn from secondary 3, there is no such thing as Cl. It needs to be diatomic 2. And it will become Cl2 lah. So this is 2 and this is 2. Will this be okay, Evan?
Yeah. Okay.
Now, the minus represents the electron being pulled out. I take electron from. So, your teacher will say there is no such thing as a minus in a reaction. There's no such thing, even though it makes some sense. So instead, acknowledging that, there is a taking of electron, we move it to the other side and it becomes plus 2 electron. It's basically math. It's basically door. Do you understand, Evan?
Yeah.
Do you understand, Sun?
Yes.
When they write electron on the right-hand side, they are basically saying, oh, actually pull it on the left-hand side. But they will never allow minus in chemistry, so they have to compromise and write it on the right-hand side with a plus, exactly like math. This is just doctrine. Are we clear about this?
Yes.
So these are the two reactions that you see, Sir and Eben, and your class should be stopping at this point, correct?
I think so.
Okay, Eben, you follow?
Yeah.
Okay, I won't go more than that, Sir, and you will get all the details. If you can think until this point, the other details are extremely easy. Who is cathode, who is anode, how to combine all this. These are what you do when you study the chapter. So you should do that, but that's the easy part. If you don't get the first thinking part, nothing makes sense. Eben, so therefore, I only teach you the first thinking part. This reaction happened and this reaction happened. You follow, right, Eben?
Yeah. Okay.
Okay. Sir, okay, yeah?
Yeah.
Remember, your teacher and the exam will ask for more details, but those details are easy. Yeah, easier. Okay. Now, I haven't talked about this one. I'll just put a question mark here first. I will now give you a second example, okay, of the battery. The battery is like that. The battery is like the electrons. What is the first thing to do, sir?
Draw the electron.
And how is it?
The is going like left.
Okay, going out from the small guy and going in from like that. Okay, and
Yes.
this truly determines what reaction. Now, Eben and Sun, I will show you the next step. Okay, the next step is saying like this. I do not want to heat up the NaCl into 800 degree. It's very trialing and actually very dangerous, by the way. You will never get to do that in a lab. One more time. This one looks very simple, looks very basic, and you will never do this in the lab. 800 degree is terribly dangerous, and the end product is also terribly dangerous. You will never have this as a working thing, never. Okay. Now, what will likely happen in lab is that now here you have an ACl, which is aqueous. That means room temperature. Okay. So let me confirm you have not reached this part.
No.
Okay. Now, Eben and Sean, your understanding hinges on whether you can predict the reaction or not. Yeah. Again, in this part, electron is being pumped in. He is attracting an NaCl is basically Na plus aqueous and Cl minus aqueous. This is what you should know or should automatically think. Let me confirm. Eben, are you comfortable with this?
Yeah.
Yeah. Sean also, yeah?
Mm-hmm.
So now you have an option. No, now it's still same thing, right? So Na plus, Na plus. Okay, Na plus is still congregating next to it. So make a guess. Will the same reaction happen?
Yes.
Interestingly, that's not the case, and both of you need to understand why. The reason is because aqueous means there is water. Water is everywhere in this case, and water does its own thing. Water can also split into a pair of H and OH. Do you know this, son?
Yeah.
Do you know this, Eben?
Yeah.
So this negative feeling thing, because the electron is being pumped to it, will attract not just Na plus, but also H plus. Still making any sense, Eben?
Yeah. So,
Because now H plus is available. What happens to the H plus here, sir?
It's not there.
Good, because it's being heated to 800 degrees. There is no water.
Oh, yeah.
The source of the H plus is from the water. Okay, make no mistake. So now we have water. Then we have H plus, and then the H plus goes all the way back there. Now I'm telling you basically the Na plus will not win. H plus will win. What you need to understand is why. Son, you have gone through reactivity series, right?
No.
Oh no. Eben, you have also not gone through reactivity series.
reactivity.
Never. Okay. Now both of you, especially for you, Son, this will appear very weird. You're supposed to learn reactivity series first before electrolysis because the explanation used in electrolysis is reactivity series.
Oh, yeah, no. There's like a table about it in
Yeah,
this chapter.
yeah. And we better understand it a little bit. Now, Eben, that means you're understanding a new thing, but who cares, right? We have been always studying new things, right? And this new thing is going to be important. Again, nothing new. Just accept it along the way. Can Eben?
Okay.
Okay. Don't panic if you're learning a new thing. You are learning a new thing. Okay, that's a good thing. Okay, now I'm asking you to use your muscle, not muscle mem. I'm asking you to memorize a little bit first. Okay, let's do that. Let's take your paper and write this for me. Okay, you're not gonna understand what's going on, but just do this. Dot, 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 dot. I have drawn a C, a H with 3 dots on top, 3 dots in the middle, and 3 dots in the bottom. Please do that in your own paper. Tell me when you're done.
Done.
Okay, Evan?
Yeah, done.
Okay, I am going to introduce to you an order of many metals. Many metals. Okay, and you're gonna memorize the order and I'm gonna explain why. Okay, first of all, there's a metal group 1. So all the group 1 metals, that's it lah. Metal group 2, metal group 3. Okay, not so difficult. Now the bottom 3. The bottom 3 is the Olympic medals. Eben, tell me what are the Olympic medals?
Gold, silver, bronze.
Good. Now, bronze is alloy, so I'll just say copper, Ken.
Okay.
Copper is here, silver is here, and gold is here. Not by coincidence. And
Okay.
copper, silver, gold. Then, Sean, what is the most useful or most practical metal, most widely used metal?
Sodium.
No, if you use sodium everywhere, things will explode, correct?
Oh, yeah.
Yeah, so sodium metal is not the most used metal. What is it?
Um,
Not in lab, okay? In real life here.
Iron.
Iron, yes. What is the symbol of iron?
Fe.
And just very nicely, it is in the middle. How convenient. Okay? How convenient. Above is maybe a metal you know, it's zinc. And a metal that you hopefully never touch because it's slightly poisonous. But it tastes very sweet. So it's weird, right? PB. There, we're done. We need to memorize this. Can? One more time, eh? One more time. Ding, 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 ding. I'm erasing everything. Start with the C, don't know why. Start with H, don't know why. Triple dot, triple dot, triple dots. We start here. Group 1, Group 2, Group 3. And then CU, AG, AU, your Olympic medals. The most common metal, iron, ZN, and PB to complete things. Okay, any question in memorizing? So, and then, Evan?
No.
No.
Give you 1 minute to do whatever you want, and then I'm going to erase it and going to rewrite things.
Sorry, the 1, 2, 3 are
Group 1, Group 2, Group 3. So for
good.
now, it's always a metal from Group 1. Make it easy lah.
Oh, okay.
Hmm. Okay, so Evan, whether you're ready or not, in memorizing, I already teach you what is important is to recall, not to look at it and think about it. Close your own notes or whatever, do it on a, don't look at them, do a blank of paper, and then please rewrite what happened just now. It doesn't matter if you don't understand. Okay, please do. Okay, Sean and Evan, are you roughly, done lah?
Yes.
Evan?
Yeah.
Okay, just to confirm to you, it should be like this, triple dot, triple dot, triple dot, group 1, group 2, group 3, very easy. And then this is CU, AG, AU. And then this is FE, ZN, and PB. Did you get everything right, Evan?
Yep.
How about you, Sen?
Yes.
Very good, right, not that bad. Now, let me explain what this means. This is a list of metals. I know that carbon is not metal. Hydrogen is not metal. Soon enough, you realize why it is in here. You just ignore them for now. The rest of these are metals. By experiment, okay, not by theory. By experiment, it turns out, for example, in group 1, there's a sodium metal called sodium lah. Turns out, sodium is just way more reactive than Fe. It's just true that way. Okay? You can prove it again, not by theory, but by experiment. For example, Sean, has your teacher drop a sodium metal into water and they react basically and then it catches fire?
She showed me a video about it.
Not very nice. Okay. How about you, Evan?
Uh,
No, never. Your teacher have never done this in the lab.
this arrangement.
Sodium, no, not this arrangement, but has your teacher drop a sodium metal into water in your lab before?
I think so.
All right. Right. Now, if you have seen this in video, you will know that a sodium metal, when dropped in water, will very quickly catch fire, which is very weird. Have you ever dropped your, I don't know, have you ever dropped your, I don't know, a lot of things are made of metal, right? Have you ever dropped your chair made out of steel into water and it catches fire? That doesn't happen with metals in daily life, right? Correct or not?
Yes.
Because we use metals which are not going to do that. You don't want to spill your hot tea or hot coffee into your chair made out of steel and the steel catches fire, then your whole house burned down. Okay, that escalated too quickly. An Fe is in the middle because just imagine that the metal in the middle is not very violent, not very reactive. Okay, this is called not a metal series, but a metal reactivity series. It actually sounds like what it's saying. The guy on top is extremely reactive, and it really sounds like that. The guy is violent, you know. The guy likes to react too much. You say something, it reacts and it hits you. You didn't say anything, it hits you, whatever, right? Okay. Sodium metal is like that. That's why we don't use sodium metal. Then everything explodes. We use Fe, just nice in the middle. What happens, Eben, if you spill water onto a steel chair? What exactly happens?
Water onto a steel chair.
Yeah, what will happen?
Water.
To a steel chair? Yeah, what will happen?
Not like what? Nothing.
Very good. That's exactly what we want with our steel chair. Nothing should happen,
Okay.
right? But if you leave it for 2 weeks, it will rust a little bit, lah.
Yeah.
A little bit, lah, which again implies that it's a very slow kind of reaction. That's what I want from my chair. Strong, stable, and don't react too much, please. Something like that. Make sense, guys?
Yes.
Yeah.
So why don't you make a chair out of sodium? So
Because it will explode. It will catch fire.
if
Like
you put
the
fire.
water.
Yeah, if you put water. Then you cannot even sweat, you know, sir. You sit on the chair, you sweat, you explode. Boom. Okay, not very fun. Okay, but exactly that will happen. Exactly that will happen. A reactivity series by experiment, keeping it simple, by dropping metals into water, they kind of figure out certain metals are just more reactive than the rest. I'm gonna flash it out for you. A certain metal called potassium, K, is even more reactive than sodium. Okay, so it explodes faster than sodium. Something like that. Calcium, magnesium, aluminium. There you go. A list of metals based on how reactive they are. Magnesium actually reacts with water very slowly, bubble here and bubble there. Still, that is not what happened with Fe, right? Now, never mind silver and everything. Silver will react even slower. This is a list of metals according to their reactivity. So, let me confirm, this is the first time you see this?
I think I did it in the holiday tuition once.
That's all. That means not in class, right?
Yep.
Eben, also the first time.
Yeah.
Now, I guarantee you that this will be useful in many questions. Right now, we're just focusing on electrolysis. Right? So what is the function of this thing in electrolysis? All right. Now, I have to explain one more thing. We have some time. Now, I miss holiday. Right? We are almost running out of time already. Now, a reactivity series represents a very simple thing, right? Represents the reactivity of the metals and also the fact that when metals react, when Fe reacts, Fe does react, okay? It rusts. It's just very slow, okay? It does react. There is no other way. It will become Fe, well, ions. In this case, I'll pretend it's Fe3 plus. You guys are chemistry students. You understand this, If we say Fe metal reacts, then confirm 100%, it simply becomes metal ion. That's what it means. There is no other way around it. It's not that complicated. Sun, Abin, you okay?
Yes.
Now,
Yeah.
Ag, silver. Silver actually do react even slower. That's why you use silver as jewelry. Do you have a silver jewelry, maybe, Sun?
Yes.
And you wear it close or on your skin, correct?
Yeah.
Tell me why you do not want to wear a stainless steel jewelry.
Um, I don't know, it makes my neck itchy.
Correct, because it reacts very slowly, but it reacts. Silver does not make you itchy. Why?
Because it reacts slowly.
Even more slowly. We're talking about decades here, right? So it doesn't make you itchy. Simple. And if you have a gold jewelry, even better. Yay, right? Correct? Now, the Ag metal do react according to your experience. Not at all. I'm not itchy. Good for you, Sean. It does react chemically, theoretically. What does it become? Sean, there's no other way. It becomes,
Huh?
again, an Ag metal when reacting becomes, come on,
Uh,
Ag plus,
yeah.
metal ion. Your chemistry student understand this. That's all there is. Okay, now, Evan, zinc. When zinc reacts, zinc becomes, come on,
Zinc
yeah.
becomes
Mhm.
zinc 2 plus. What?
Yay!
Okay.
And there's no other way about it. That's it. Both of you are way overthinking this. A metal, when reacting, it becomes metal ion. Okay? The metal's life goal is to become metal ion. They tell you this in Sec 3, man. A metal longs to lose electron. So when it has the opportunity to do it, it will do so. We call that reacting. A metal reacts to become a metal ion. Case finished. Problem solved. That's it. That's really it. If you want to learn chemistry, at least understand this part. They teach you this quite early. We just don't get it yet. Eben, Sean, okay?
Yes.
Sean, Mg, if it has an opportunity to react, becomes...
Mg plus.
You do have to memorize it's Mg2 plus lah, but your mistake is only on the how many plus. At least you have a concept of it becoming a plus, okay?
Yes.
Ca, Sean, becomes...
Ca2 plus.
Yeah, because it's group 2. Eben, Na becomes?
Na plus.
Yeah. So in the reaction, sodium metal drop into water, fire explode, blah, blah, blah. The sodium disappear, Eben and Sean, correct?
Yes.
Why did the sodium disappear? Magically, why, Sean?
It reacted.
And it becomes?
Fire.
No, it becomes sodium plus. Hey, chemistry student. And therefore, it has no appearance of metal anymore. As a metal, it disappears. It becomes sodium plus. Where is the sodium plus in the experiment? Come on, sir. Come on.
The liquid, the molten.
No, it's not molten. A molten sodium is not this. It is now inside the water dissolved. And the water seems to turn red. Do you remember anything like that?
I think so.
Okay, never mind. The metal disappear because the sodium becomes sodium plus. What happened to the sodium plus? It just enters the water. And so you cannot see any metal anymore. Eben and Sean, is this okay?
Yes.
Sean, Eben?
Yes.
Yeah.
Okay. Now, a reactivity series has a counterpart here. This is the mirror image line. Mirror image line. Okay, whatever is on top here, which are metals, we have a mirror image here, which are not the non-metals, that's wrong. This is the metal ions. Okay, let me repeat this one more time. If you see AU here, then the AU2 plus will be here, very close. It's a mirror image. If you see the CU here, then the CU will be here in a mirror image fashion. Do you understand what I'm saying, people? Okay, this is a mirror image fashion. Now comes the explanation. I told you, right, electrolysis requires too many explanations. This is just one of them. I was trying to resolve this problem. Who wins between H plus and Na plus? I'm going to show you right now by first asking you, Sean, is there any H plus? Is this whole situation? Is there any H plus? Here,
Yeah.
where is the H plus?
Above copper.
Above copper. That's H, not H plus.
Oh.
Where is H plus here, son?
Um.
Think carefully, yeah. Do you see Cu here?
Yeah.
Do you see Cu2 plus?
Yeah.
There you go. So, do you see H?
Yeah.
So, where is H plus?
Below.
Who?
AU.
Below AU here. H plus.
I don't know.
The mirror image is a mirror image. Come on.
Below Cu2 plus.
Wonderful. Correct. Evan, you okay? The mirror image thing.
Yeah.
Huh? Whether this makes sense or not, son, you have mirror image successfully. The H plus will be there. Anyway, H is different from H plus, so you need to know that. Can? Can?
Yes.
Now comes the solution of the problem. Now, this reactive series should have been studied in a different chapter. Saja is like a second nature to you. Right now, well, you're learning it like, because for some strange reason, you have not learned this. And then you will be learning this, so you're ahead. Now, the issue is who will win, H plus or Na plus? Just remember the first situation. In the first situation, there is no competition. There's only Na plus. So Na plus will accept the electron and become a sodium metal. You still remember that, so Annabelle?
Yeah.
Annabelle, okay?
Yeah.
Now, back to the reactivity series. This represents something like this. Here's your Na plus. Here's your Na plus, right? This is it. This is your Na. This is your Na plus. By accepting an electron, he becomes a sodium metal again. Look at that. Okay, so Annabelle, this is okay?
Yeah.
There is a very big jump up. This is a very intentional representation. The jump up represents a very high energy requirement. Sodium plus becoming sodium requires a lot of energy, not just an electron. But it will happen if you set up. Okay. Now we have a competitor, right? Remember, in the second situation, when the NaCl is aqueous, we have a competitor. The competitor is now, of course, Na plus and H plus. So, where is the H plus?
Below Cu2 plus.
Right. And let's say H plus wins by, receiving the electron. What does it become?
H.
There you go. And that is represented by a jump up, also a jump up. Receiving one electron also, but you notice the difference in the jump up. Eben and Sean, you notice that?
Yes.
So, Eben, you understand there's a competition for the electron here?
Um, Not.
One more time. This is the situation. Remember, electron going in. The liquid here is NaCl aqueous. So you have Na plus and you have H plus from the water, right?
Yeah.
Both are attracted to the site where there are many electrons coming in. Yes?
Yeah.
So therefore, there is a competition on who will grab the electron. Yes or no?
Yeah. Oh, okay. Yeah.
Okay, that's what it means. That's what it means. A competition. That's a competition. There's only two competitors. Evan, can you predict who will win? Who will win? Sơn, you also think lại á. Evan, you think? Who will win?
Not sure.
Not sure? Take a guess. Come on, Evan.
The one above the mirror, right?
Okay, H plus or Na plus? Who will win?
H plus.
All right. Okay, you have made your guess. Thank you very much. Sơn, your guess.
H plus.
Now, do you have a reason, Sơn? Because you're studying this chapter, right? Do you have a reason?
Cause it takes lesser energy.
Thank you. That is the exact phrasing they will ask you of you. And you are correct, both of you, Eben and Sơn. In this case of this, in this competition, H plus will win hands down. Okay? H plus will grab the electron and Na plus will not grab the electron. Eben and Sơn, okay?
Yes.
The explanation in this long-winded reactivity series, because you haven't studied. If you already studied, it's supposed to be second nature. Back to the explanation. So therefore, this reaction will not happen. Understand? It will no longer happen. H plus plus electron, okay, will become H, but all of you know in Sec 3, H cannot exist by itself. It has to be a diatomic. H2, 2, 2. This will now be the reaction. So, you understand?
Yeah.
Eben, do you understand?
Yeah.
Different setup, different reaction. Okay, we haven't covered what happens here. We only covered what happens here. Okay, such a long explanation for just a simple matter. However, Eben and Sơn, to memorize is also not an option. Might as well don't study it then. Memorizing it, they just change a little bit, you're dead already. You end up having to understand it. Now I'm not sure that's a good news or a bad news, but as far as I can tell, both of you like understanding. Okay, you just understand this once, you'll get every other situation. I'll give you another good news. The reaction itself is so simple to write. The thinking behind takes some time, but the end answer or the end result is in general very easy to write. So it's like physics look, Eben, very difficult to think, but once you get it, the answer is usually seems simple lah, something like that. Okay, Eben?
Okay.
Okay, but we are now running out of time. So, and for now, is this good enough?
Yes.
Okay, we'll try to cover more next week and we'll discuss more plan. We don't even have time to discuss plans. So, and that's how troublesome electrolysis is. Okay, tell me what happened next week and I'll see both of you. All right,
Okay.
bye.
Bye bye.
Bye. Thank you.
You too.
Yeah.